Well, good morning, everyone. I'm so happy that we were able to gather such a large, engaged, interested, and international crowd today. So I'm Aidan Morrison, the Secretary General of the Nordic Navigation Forum, and it's my pleasure to welcome you here today. The opening address is going to be given by our president, Heidi Kuusniemi. Dr. Heidi Kuusniemi, the president of the Nordic Institute of Navigation, is a professor in computer science focusing on position technologies and systems at the University of Vaasa in Finland. She also leads the Kvarken Space Center at the University of Vaasa, which focuses on promoting satellite data innovations. She is also a research professor in satellite navigation at the Finnish Geospatial Research Institute of the National Land Survey of Finland. So if you could say good morning to Heidi, she will take it from here briefly. And then next we have an exciting panel coming up. So you can look forward to it.
Thank you, Aidan. And good morning, everyone. It's my great pleasure to welcome you all to today's event, Findings from Jammertest 2024. So as the president of the Nordic Institute of Navigation, I'm very proud to see such a high-level gathering of experts, policymakers, also researchers, and then industry leaders today, all united by a common goal to ensure resiliency and reliability of PNT, position navigation and timing systems, in a world now where GNSS vulnerabilities are no longer theoretical, but a daily operational reality. And I want to start with thanking all of the organizers of Jammertest and this event here, and also the event co-sponsors for this event today. We all rely on GNSS every second. PNT, critical and vulnerable, the backbone of our global digital infrastructure. The threats are rising that we are focusing on here today, and resilience is no longer optional. Jammertest provides us with the real-world resilience testing that we need to building PNT resilience, controlled GNSS interference testing, realistic conditions, realistic consequences, also in a wide cross-sector collaboration. And with the experimental data from this excellent experimentation campaign yearly, this brings us data to drive PNT innovation forward and also policy. Especially here in the Nordics, this is the reality that we are facing, the recent GNSS vulnerabilities in the past couple of years. You can see some media extracts from Finland, Sweden, and Norway, and of course the list goes on. And these are the vulnerabilities that we focus here, and we have on the agenda today field results to build the future more resilient PNT, technical insights, advances in alternative and hybrid PNT solutions, new perspectives from industry research and also the public safety sector, and then looking forward what's next in this year's Jammertest and also beyond. So without further ado, again, a warm welcome to everyone. It's going to be an exciting program ahead, hopefully also exciting networking and exchange of thoughts and ideas. So a warm welcome, and that was my initial remarks here, and let's move forward to the panel discussion. Thank you and welcome.
I'm happy to announce today that we have 6 distinguished panel members here with us who are going to share their insights to the various aspects of Norwegian society that have come together to make Jammertest an event and to help us understand why it's so important. So if I could ask our panelists to come forward. We have 6 seats here with 6 chairs. You'll have to share the 2 microphones, so I'm sorry for that. In today's panel discussion, we'll be discussing critical issues of jamming and spoofing. So we are honored to have distinguished representatives from various key organizations with us today. Our panelists include, and I'll introduce you individually afterwards, I'm just listing you right now. So we have Bjorn Lak Formso from the Norwegian Public Roads Administration, Trygve Spar from the Norwegian Defence Research Establishment, Johnny Vella from the Norwegian Mapping Authority, Geir Samuelsen from the Norwegian Metrology Service, John Eivind Velur from the Norwegian Communications Authority, and Christian Haugli Hansen from the Norwegian Space Agency. During the panel, we will explore the impact of jamming and spoofing on different sectors, discuss the importance of cross-department collaboration, and delve into preparedness and total defense strategies. So I would like to introduce you individually, if that's okay, so the audience has an idea of who they are listening to. So Trygve Spar first. Could you say hello? Hello. Yeah. Thank you. Perfect. Trygve Spar is Director of the Sensor and Surveillance Systems Division at the Norwegian Defence Research Establishment. He holds a doctorate degree in physics from the University of Tromsø. His area of expertise is experimental physics and sensors with an emphasis on radar. Dr. Spar has broad expertise in sensors, analysis, operational processes, and ICT systems. Very good. So after this introduction, I'm going to be asking them each individually a very specific question. So you might have noticed that I have not proceeded through your whole bio because I want to save some of that as it's relevant for the answer. Next up, Bjorn. Could you say hello? Hello. Bjorn Laksformo serves as the division head of the Norwegian Public Roads Administration. Bjorn has been pivotal in enhancing the robustness of road infrastructure against various threats and has a wealth of experience in resilience and total defense strategies. His role in the context of Jammertest is his continued commitment to ensuring the security and reliability of critical transportation in both physical and digital infrastructure. Welcome, Bjorn. Next, Christian Haugli Hansen. Sir? Yeah. Christian is Director of the Director General of the Norwegian Space Agency, a position he has held since June 2018. NOSA is an agency under the Ministry of Trade, Industry and Fisheries. NOSA is responsible for implementing the Norwegian government's space policies, hereunder managing Norway's participation in the European Space Agency, as NOSA is furthermore responsible for the development of national space programs, bilateral activities, as well as being an advisor to national space industry. He previously also held the presidency of NIFRO, the advocacy group for the Norwegian space industry. Welcome. Geir? Yeah. Geir Samuelsen has been the Director General of Justevestnet since 2017, before that holding the position of Director General of Norsk Akkreditering, as Assistant Director for the Norwegian National Security Authority and various positions in the MOD, including assignment to NATO headquarters in Brussels. Glad you could be with us today. Jon Eivind? Yeah. Hello. John Eivind Velur serves as the Director of the Norwegian Communication Authority, NCOM, the executive, supervisory, and administrative authority for postal and electronic communication services in Norway. Over time, Jon Eivind has emphasized the value and importance of protecting the PNT data provided by GNSS systems to the Norwegian digital infrastructure and society. And last but not least, Joni? Yeah? Joni Vella is Director General of the Norwegian Mapping Authority. The Norwegian Mapping Authority owns and operates the Norwegian GNSS ground infrastructure as a foundation for Norwegian positioning services. Joni is dedicated to strengthening this critical infrastructure and investigating and predicting the disturbances that may influence the services offered through it. So welcome all of you. I hope now the audience can better understand why we're so happy to have this collection of specific individuals with us and why they are very relevant to the discussions today. So, as panel moderator, I have to warn you that the Norwegian police are in attendance, so please don't get too unruly. I haven't passed that with them before, but I'm hoping they would help me out if you get too unruly. And you'll have to share a microphone, unfortunately, so please play nicely amongst each other. The first question I would like to ask to each and every one of you in order is, can you briefly tell us why you and the organization you represent are involved in Jammertest? Just maybe a minute or two each, please. So could you begin? You're closest.
Okay, thank you very much. This is on?
Yes,
yeah.
I believe so. Michael, that's on? Great.
That's good. Thank you for the question. Thank you for the nice introductory words. Nice to be here as well. For us, we have the responsibility to protect the radio spectrum. This is a critical asset. So that's the start of it. Our role is to protect the spectrum, and we have the responsibility to also secure communications networks. And we all know that the dependency of GNSS signal is very high and increasing, still increasing. So also for the electronic communications network, GNSS is very important and critical. So I think that this collaboration and cooperation is very important, so that we get a common understanding of the dependency of GNSS, and also try to find methods to how to protect it better, and also have a better resilience in the systems. So that are a few moments, that a few items I will emphasize. And this, I guess we can come back to it, but I think the cooperation also brings with it a lot more than only this GNSS item, because we learn from each other on many different things by participating in a Jammertest.
Thank you.
I'm head of the Sensor and Surveillance Division at FFI. We deal with surveillance in a broad sense from outer space to the bottom of the sea. And we have been involved in space activities a long time, and also in the PNT and GPS from the very start. And the reason we do this is really threefold. First of all, as we are a research institute, we want to have a deep understanding of all the technical and operational aspects of PNT systems. And that's the foundation that we build our two main lines of effort from that on. And one of them is to give the advice to the Norwegian defense on all aspects of PNT and how they can utilize it to the best effect, and at the same time what kind of vulnerabilities and threats that will expose the defense to. That also, in a broader sense, has been very clear over especially over the last few years, that this applies to the total defense aspect as well. So the entire society needs to know about how to use, but also how to protect the use of PNT systems. Then the final thing that we rely very heavily on PNT is for our own developments, especially in the field of autonomous systems. FFI has always been very heavily involved in advanced navigation systems, the combination of GPS and inertial navigation for various kind of autonomous vehicles, both underwater and on the surface and in the air. And to be sure that this kind of systems can be operated reliably, we need to know a lot about both how to use them and the vulnerabilities. And the research into vulnerabilities in the GPS and other GNSS really started 20 years ago for us. And it's been very clear that this is must be a prioritized area. For defense, it was clear back in 1991, during the first Gulf War, the precision-guided munitions at that time gave the US-led coalition a very clear asymmetrical advantage over the Iraqi forces. And that was to a big extent enabled by GPS. And when that was clear, it became clear to all kind of militaries around the world that counter GNSS systems would have a big impact as well, and would be important. And that's something we see very clearly today in today's conflicts, like Ukraine and Israel and other places, that to dominate this area is important, and to protect our own systems, we have to do GPS's effects and try to jam them out. So that's and of course also for our, we have been very closely involved in Jammertest from the start, and that's because we want to both develop all those lines that I talked about, but also because it's in itself is an important capacity to have, to be able to do the kind of jamming that we do there. So That's mostly from FI.
Thank you.
Thank you.
Yes, thank you. And as you mentioned, we are in the Norwegian Mapping Authority. We are operating the ground-based infrastructure consisting of approximately 300 base stations. And this infrastructure is, of course, then underpinning the services related to high precision positioning for more than 18,000 users across the country. And by being at Jammertest, we can try to understand how the interferences affect to these services and to this infrastructure. And this is by being there with our competence, sharing competence, as your name says, sharing that competence with others, and an understanding both how to monitor and how to build resilience to that services is a very important place. That's why we are there, and we are also there. We want to mention that we are also there to support the other participants with those services at site at the Jammertest. So we have a service offering by being there. Lastly, I would like to mention that we also are interested to understanding how high resolution maps can be a part of any what do you call alternative ways of autonomous vehicles or positioning as alternative measures.
Thank you.
Okay, thank you very much for the invitation. And I would like to start with, I was very encouraged by the opening statement to this conference, and we've spent some time looking into the results from the previous Jammertest. This just plays into the importance of the whole event, and the broad range of participants is truly telling in terms of what this means to the community. I have 3 points I would like to emphasize. First of all, the role of the space agency. You mentioned that briefly. We have a role of being a strategic advisor to the government, but also being the advisor and coordinator towards the European Space Agency and the EU, the EU space programs, in particular the Galileo, EGNOS, PRS programs. And also we are coordinating those activities between the government, the institutional organizations, and national industry and institute. This is a very essential and central part of our role. So that obviously provides some reasons for us to be part of this event. The second point is the important element of PNT in general. Part of our mission, I mean, we are administrating the national funds for space, but the space services is really at the heart of this. If we cannot justify the importance and the use of the national services in this particular case tied to navigation and the PNT services in general, you know, that's part of our job to make a justification and make this work. So that is the second point, and the third element is obviously the importance of space in terms of PNT. The development of Galileo, we've been part of that since the onset, 20 years ago. And we have followed that through our participation in the various committees, both in program boards, both in ESA and the EU. And we think that we're playing an important role in bringing that information home and providing that within our colleagues here in the panel. So that's the reason why that we are here. Thank you.
Thank you.
Good morning. Thank you for putting us in a panel like this. I think it illustrates the fact that we couldn't have done this by ourselves.
I thought we were putting you on display, so thank you for...
Yeah, and I mean, each of these organizations, I mean, this is putting together a unique test facility, which would be impossible to do it by ourselves. We have a specific deliverable from the Norwegian Meteorology Service. I mean, for obvious reasons, we are extremely interested and in accurate time. I mean, that's one of our major deliverables. And we're very concerned about the dependencies of the accurate time in the critical infrastructure. Of course, if you can mention telecom, the power supply, the transportation, aviation, and even finance. Well, to illustrate it, requirements for accurate time in the digitized power supply, and also that corresponds to the requirement for the synchronization of the 5G base station. I mean, we're talking a microsecond. And a few years ago, we started to work with Statnett closely to reduce the dependence on the GNSS time. This becoming an increasingly vulnerable source, as of course you mentioned. And during this work, we have established in our organization the capability to create false GNSS signals. And that is, of course, to test the resilience of relevant equipment. And this is, of course, my point. We also worked quite closely with the Norwegian Space Agency and has led to our contribution to the Jammertest, which is the spoofing signals. In addition to, of course, being part of the whole event, contributing with our expertise on, in particular, time. Thank you.
Thank you. Our entrance point into this is that the use of new technology obviously expands possibilities, but it also introduces a lot of risks that were previously unknown or unaddressed, or increases some of the smaller components of that, like time, for instance, that has increased importance in the utilization of the technology that we would like to utilize. So getting the knowledge and the insight and a systematic approach to how to mitigate those risks is vital in order to utilize the possibilities that the new technology provides. Secondly, in addressing those risks, I believe it's vital for the state agencies to take a firm position and collaborate, because we are, in essence, one of the key providers of the necessities that all the industry work, collaborations need in order to mitigate those risks. So by doing this, we have a collaboration that enables our government to address these risks in a way that actually enhances the possibilities that new technology provides. And thirdly, this is not done by the government or the states alone. The collaboration with the industry is vital, and setting an agenda or a sandbox that enables us to share these risks, share these mitigations, share this knowledge is vital in order to enhance the options or the possibilities that new technology provides.
Thank you. Well, I'd of course like to take this opportunity to dig a little bit deeper into your sentiments, and I wouldn't be a moderator if I didn't ask specific people for feedback. So this time around, rather than just going through the whole group, we're going to ask a question to specific individuals in order. Everybody will have a chance to give their opinion, of course. But digging a little deeper into it, jamming and spoofing pose significant challenges across different industries, affecting everything from road safety and military operations to mapping services and communications technologies. Understanding these impacts is crucial for developing effective countermeasures and ensuring the reliability of our critical services. So I'd like to start with Jan Eyvind first. How does the Norwegian Communications Authority work to regulate and monitor the use of frequencies to prevent jamming and spoofing, if such a thing is possible?
Yeah, it's a big question, of course. First, I'd like to start to say that jamming is illegal. That's obvious, perhaps. But if you do it, then you can risk, of course, a penalty. So, and we have the means to follow this up, but what to do to prevent it? It's quite difficult, but. We have a lot of monitoring equipment that we can that we use throughout the country to also to monitor the spectrum. We also are developing systems that can detect more on an automatic level that interferences occurs. That is also that is jamming, but also a non-intentional interference that occurs. We also need to inform the society, and we do a lot of that, and also Jammertest is a part of that, to inform about both the dependencies that you have for these signals, and that it is of course illegal to use jammers, and we see the effect that this has. Hopefully, we need to do more of this, I think, to provide this information. We also see that this collaboration throughout these last years has led to that also government is more aware of these dependencies that we have for GNSS systems as a whole, and they are also willing to do more to protect them, but also to come up with alternatives, and that is one main point, of course, that okay, we have a lot of dependencies, but what are the alternatives to GNSS? And all players, all industries, they need to think about how to also have secondary systems that you not only dependent on one system. So we cannot solve this alone. That is one key takeaway, I think. That is also why we are sitting here together, because we collaborate and we use our experts in a way that leads to more resilience in the society. So we have some means at our level, but that cannot solve everything. We need help from each other to make this better.
Yeah, I hope you understand why I asked you first, but you're not last on this point. Yeah. Thank you. Geir, how do jamming and spoofing affect measurement technology and calibration services? I'm guessing the answer is not in good ways, but I'd like to hear it from you.
Is it working now?
Michael, is that working now?
Okay. I probably won't answer your question now. That's better. Oh yeah. Well, I think again what we're trying to do in this context is enabling, a really thorough real-life testing of various equipment, and to boost the innovation, leading hopefully to the better projects each year for each Jammertest. Which again, then we have to stand ready to work with this equipment and work with these suppliers and manufacturers. Let's face it, I think nothing boosts innovation like a dissatisfied customer in the same room as the manufacturer and the supplier. And I think this is what we see during the Jammertest event. And again, not probably answering your question precisely, but this is what we think is one of the important things to get out of these weeks. And we will again stand ready to contribute with our technical expertise and to work with these manufacturers to improve their products.
Well, I thank you for being candid that it didn't directly answer the question, but anyone on the panel can feel free to not answer the question I ask, but the question you wish I had asked. So we can loop back later or catch you on the coffee break if we really want to dig into it. Yeah. So next up, Bjorn, moving on to what's happening out on the roads. How do you view the challenges of jamming and spoofing in relation to road safety and traffic management?
Yeah, I'll answer your question firstly.
Thank you.
I'll do it in two entrance points. One is the utilization of the possibilities, and that is traffic management. Of course, traffic management is dependent on knowing where the traffic jam is actually present at the time or will be present at a future time. which cannot be solved by sensorics on the road infrastructure alone. It will need some sort of interoperability with exact positions on the road from the vehicles. So actually having the correct positions, the correct time, the correct everything, in order to both resolve and predict is vital. Secondly, on the how to avoid risk entrance, which is traffic safety, really. We have, throughout the years now, been moving towards a zero vision on traffic accidents. Done so by methodically introducing new action points into the traffic systems. And the driver assist systems is one of the key points in order to do that. But that also introduces new vulnerabilities, because the driver assist systems are dependent on something in order to make the drive assist actions possible. So in order not to introduce new vulnerabilities that damages the traffic safety that we have been doing for a few years, we need to be in advance of that particular issue.
Thank you.
Did I answer your question?
I believe you did, yes, and I'm glad you mentioned null vision as well, yeah. Joni, how do jamming and spoofing impact the accuracy and reliability of mapping and positioning services? Again, I'm guessing not well, but you choose how to answer that question.
This is more like the exam. Okay.
It can be if you're okay with that. If
Okay,
not, yeah. You could answer not very much. Our stations are distant from the roadways.
Yeah, geospatial data is, of course, increasingly more precise and more dependent on the GNSS. And what we see, for example, from surveying missions in north of Norway, that we have really big problems with the accuracy of the data from the planes that flies over and giving. So, of course, for our own business, it's damaging. But as I mentioned earlier, I think the one thing that we can chip into this collaboration here is that we have this infrastructure that can be used both in monitoring for the EU space services, but also for building a more robust monitoring system across different sectors, because these base stations, they can monitor interference and give data into perhaps a broader network, which we don't currently perhaps have, but we should investigate into. And then also we see that we of course can, like in the foil earlier, to build hybrid PNT services, and perhaps we can use some of our competence and the services that we have to collaborate to building those hybrid PNT services, mitigating this jamming and spoofing. Mm-hmm. So we're quite curious about that area as well. Mm.
Oh, thank you. So I would also like to give the last two panelists a chance to make any comments they want to the overall question, since they haven't been specifically asked any. So do you have any thoughts to the overall question? If not, it's okay that we can just move on to the next one. I just don't want you to leave you without a chance to chip in.
I can comment on how to be sure that it's safe and reliable and resilient, you need to take a kind of total systems approach. And that's one of the good things by this collaboration. We have everything from very nerdy people who knows about the 10th point.
There are one or two in attendance.
And to the people who collaborate with industry and have things like road safety and mapping and spectrum safety on their table. And when we get all those things together, we get a kind of total systems view on the problems that we are facing. And that's very important to be able to deliver what we need for the society.
Thank you. Last word? No. Okay, maybe next question. Yeah. So we're going to move on to a new theme. The importance of cross-departmental collaboration. Addressing the challenges posed by jamming and spoofing requires coordinated efforts across various sectors and organizations. By working together, we can leverage our collective expertise and resources to develop more effective solutions and enhance our overall resilience. And in this frame, I would like to start by asking Geir, why is it crucial to work across different departments to address the challenges of jamming and spoofing specifically?
Well, I mean, yeah, Norway is governed by the principle, as we all know, of each minister being in charge of all the agencies and activities within their own sector, and of course, then the minister is accountable to Parliament. Hence, it will be extremely tempting for the minister to give priority to what is clearly within his or her area of responsibility, and not get too much involved in cross-sector activities. But in my view, this is not the case in the Jammertest context. And what makes the Jammertest even more special, as far as I understand, is that there are no traditional guiding documents. I mean, this is based on consensus and trust. But I'll give you an example about the cross-sector collaboration, and maybe you were going to go to this later anyway, but I can't resist mentioning it now. The fact that Jon Eivind and myself, we have been tasked by our two ministries to look into or to map the need for a national infrastructure for the distribution of precise clock signal, and based on this mapping to investigate solution for such a ground-based infrastructure. This is, I think, a good example on cross-sector collaboration, and I have to say it works very well also in practice. In fact, the Jammertest is the perfect testbed already for the deliverable of a ground-based accurate clock signal. Did I vaguely answer your question?
Not only did you answer the question I asked, but you also helped set the context I failed to set for why it's so impressive that such a group is working together. Because as you said, it would be very tempting for the sectors to be dominant and someone to say, well, that's not my problem, that's not my problem. But instead you have come together to make it everyone's problem, because it is something that affects everybody in the country. So thank you for doing my job for me.
Thank you.
I'd like to follow up with Christian, if I might. How does your organization collaborate with other sectors to enhance resilience against jamming and spoofing? So this is maybe a harder question.
Maybe.
Maybe.
Well, I think Geir's point is very important, and you touched upon it in terms of the sector principle in Norway. But I really think that the panel really demonstrates that this is not a one sector only issue. It really requires cooperation between the various ministries and the various sectors in terms of how to make this work. Going back to 2018, we issued a national PNT strategy, and I was referring to the space agency's engagement in the PNT and the Galileo EGNOS all the way back 15, 20 years. So we were part of putting this document together, and I think that was an important contribution in terms of explaining how space and the space infrastructure can actually facilitate this. So this was sort of the groundwork in terms of facilitating coordination between the various sectors. So I think that it takes time to implement such a strategy, and it may need updating, and we have discussed this. But I really think that at least there was an intention or intent to actually make this work, on the national level. That was the first thing. The next element, in terms of to cooperate across sectors and between the various national agencies, is cooperation agreements. So we think that in order to materialize what we're actually trying to achieve, you really need to put things on paper, agreeing on what is the objective and how can we implement this. So we are, with all these gentlemen here, we've signed not with you. We need to do this. No. So to sign agreements.
I have a pen here.
Yeah, you have a pen. All right. Anyway, but we are part of the same forum here, and I really think that really speaks for the importance of being coordinated. So we're trying to, again, being a coordinator, developing these joint agreements in order to make this work. The third element, this needs money, and we need to implement this to actual contracts. So in Norway we have, in our budget, over the parliamentary budget, we have what we call Post 34, which is funding for national infrastructure and services. So our part, with our experts, for our delegates, our experts on PNT, they are on, say, a technical level engaged with these organizations in order to hammer out how can we do this? What are we actually looking at, and how can this be done? The Jammertest is one thing in order to facilitate that. The mapping authority is one of our closest, well, they're all close partners, but Jan is here. So we are actually using this, and this is actually quite unique. We discussed this with the European Space Agency and also with the EUSPA, the EU Space Agency for the Galileo services. And they're saying that this, one thing is the general services that is provided through these programs, as long as you're a partner. The other thing is doing this also for implementing on national level. And I think that's unique, that we have these cooperation agreements, and we have these contracts where we can facilitate money on behalf of the space component of this in order to make these agencies work well together.
Mm-hmm. Does anyone else have anything to add to that? You do, sir, please.
Thank you, and I fully support, of course, what Christian's been saying, and I also like to, you know, the PNT is the PNT dependency is a good example of you know, cross-sectoral cooperation. We need to do that to solve problems. That is not unique. We have several of them, and the society is more complex, and it depends on cross-sectoral cooperation to solve the problems. We cannot solve them alone. But this Jammertest is a great example of a success where we actually have done these things between our agencies. Actually 6 of us now. It's I think it's a great example of how to do it, and we need to use this as an example also to solve other similar problems in the society. So I need to, you know, brag a bit about ourselves, of course, here. But I think it's a very good example. But it's not unique that we have to cooperate between different agencies and across the sectors, and that is quite difficult to achieve, actually.
Thank you very much.
Comment briefly as well, because in the defense sector, which is one of the many sectors in society, of course, when we are talking about jamming and spoofing, that is close to the field of electronic warfare, which is traditionally a very closed environment. And what we see by taking part in this kind of event is that there is a good flow of understanding and information between more traditional electronic warfare-oriented people and the civilian society people, and the key issues of resilience and reliability, which is common to all, and we can work that in a good way.
Any final words, or can we move it on? Well, then I would like to connect it backwards to something you mentioned just a moment ago, which was your problems with survey flights in the north due to the problems with a noisy neighbor. But rather than talking about the problems with the neighbors, we all have those to some extent or another, I'd like to instead focus on the positive aspects. As a member of the Nordic Navigation Forum, I would like to ask you about positive collaborations with your neighbors. We've noticed that Jammertest has been very popular with participants from around the Nordics as well as domestic companies. And then also if you could extend that to cooperation with Europe, which has already been mentioned, and cooperation across the Atlantic, which has not yet been mentioned. So this is a complex question, but I'd like you to focus on the positive.
Yeah, that's a big question. First of all, Norwegian mapping authorities, of course, have very good collaboration with the peers in the Nordic region in all aspects of our services, also the geodetic services. We are very closely connected to both Finland and Sweden. So the competence and the experience is one thing that we also see at Jammertest, at our core businesses when it comes to the more geodetic services, and we use, of course, these infrastructure to maintain our national reference frame, and so it's on a technical level, but also very useful, fruitful. But I also like to, when it comes to collaboration, to be, as I hear my colleagues state, that to be able to meet actually the vendors of the equipments at Andøya is very important. But not only meet the salespersons, but actually the guys that is building those equipments is very useful. And also then on the other side, the people that in autonomous cars, providers there, what do they actually need? How are they building in their redundant systems? How do they work with, as I said earlier, with the high resolution maps and such things like that. When it comes to more what do you call geodetic services and competence, we work of course very closely with the US, with NASA, and we have this Earth Observatory in Ny-Ålesund. It's very important for us. And when it comes to the PNT services, building a backbone, perhaps we have a atomic clock that we could put into that infrastructure if that would be necessary. So it's complex, and it's a big question. I don't know if I answered really good, but it's
you answered parts of it. That's great. I can bother the others for more information. Yeah. Yeah, I'm happy to ask to what extent you see future collaboration growing with Europe and the Nordics, or internationally with respects to these activities, whether there will be more effort to incorporate even more international participation. But I have to point out it's already at an impressive level. There were, I believe, 19 or 20 nations last year and vendors from several countries. So I wonder if it could also be used as a venue to invite specific groups or vendors to do demonstrations in the future. And if you have any opinions to such things, please proceed.
I'll try. We're having a meeting afterwards on our level to discuss also the future of Jammertest and how to proceed. And of course, this issue is a part of that question, part of that discussion, because now we have a lot of applicants to this year's Jammertest, and we will evaluate who can participate, because we don't have the actual place to take on board everyone. But I guess the participants from other countries is very important, and that will also be a part of that evaluation when we see into who shall participate. And the success of Jammertest is very clear, because it has spread all around the world, this event that we have on Andøya. So the interest is quite big also from other countries, both on authority level, but also, of course, industry players.
Thank you.
Just like to comment briefly, because this kind of cooperation is close to my heart. I mean, the answer to your question, I think this time, whether we should encourage both regional and also global cooperation, and I think that's something we should aim for, and to try and do it, of course, in the right way, which will be, as Jon Eivind said, part of our discussions after this session. I mean, I think we all represent areas that is by nature, they don't see any borders. I mean, it's a global, I mean, metrology. How you can't put together a car, you know, if you don't have metrology, because it's made in so many different various countries. That's a very small example, but you know, we rely on the unit system and everything, and we're in this together. That's another thing. So if we can contribute to more resilient and to provide building blocks in the total defense concept, that would, of course, I think, prepare us for a higher level of crisis, which I think we all need. We all think is needed. Yeah.
Thank you. And I believe you wanted the final word.
Yes, it's more of a general comment. I think that it was mentioned by you the importance of awareness. Increasing awareness around this as an issue is exceedingly important, because that's the only way that we will be able to act on this going forward. That the political level needs to be aware, and the international community needs to be aware. So this is a classical example of thinking global and acting local. I think also, at least from my personal perspective, one thing is the active jammer spoofing. The other thing is the total performance of such a system. The degradation of the EGNOS performance as a result of solar activity, for instance, is something that's being extensively discussed also on ESA and EU level, how to create resilience on this. And I really think that, you know, to expand on the complexity of the issue is really important in order to make awareness. How are we actually going to make this work? And so right now we are exploring on Norwegian level how to act on the issue of space weather. What is the responsibility, and what are the actual measures that you can facilitate in order to also provide for resilience? So resilience is really an issue that is on the minds of both the European Commission and also, say, political leadership worldwide. Thank you.
Thank you very much. Oh, you wanted to too? Yeah, please.
I understand we're moving on to total defense, which is close to my heart. So I'll just an example of the jamming, what the jamming threats, because the first spectrum is, of course, the positioning. The next spectrum is the command and control issue of it all. And in the last effect, it's also about how we as a society are managing the issue when everything is out of control. And this is hampering our management possibilities, which opens us for attacks or vulnerabilities on other issues that we are not able to focus on that point. So in that respect, if you're asking ourselves if whether or not jamming or time jamming or positioning jamming is affecting us, we can ask ourselves on the four basic necessities of the community or the society: roads, water, power, and communications. Which of those are not affected by jamming in any other sorts? And if the answer is it is affected on any level, it's just a matter of amount. How much can we able to tolerate in order to continue to have actually control of our society?
Well, since you've broached this topic, maybe we should ask the rest of the panel to also comment on their thoughts towards what is necessary for future preparations in this context to integrate total defense and make optimal use of our infrastructure, especially in the context of the GNSS vulnerabilities that we're seeing tested and evaluated via Jammertest. Please, you can go first.
Of course, this really relates back into some of the topics that we already discussed, including the sector principle, because the total defense resilience, the threats that we face, they are typical hybrid threats, and hybrid threats, they typically try to address the seams and the cracks between the various sectors and the various systems to find the weakest spots. And what we really need to do is to cooperate very closely, understand each other well, and because services are provided between sectors and also between countries and in alliances and so forth. So it has both a cross-sectorial and an international cooperation element that is very important for total defense resilience, in my opinion.
Please, the floor is open. I'm anxious to hear your thoughts on, for example, what steps are being taken within your organization to enhance preparedness and resilience against these threats? Are there active programs underway? I understand that we broached the topic of the potential national time and frequency infrastructure, so that can be an example. Can anyone else care to elaborate on what's being done? I don't think NCOM had the chance to talk about that.
I think, of course, total defense is very high on the agenda for us, not only on the PNT and GNSS dependencies, because electronic communications is you know, the baseline for everything to work. So we are participating heavily in the total defense cooperation. There was also, and you know, to strengthen the electronic communications networks, there's a lot of things going on, a lot of activities, and also the government now has promised to present a new plan, a new security plan for electronic communications systems in the coming months. So that is also, of course, something that we have been working with and provide them with information and proposals. So, and that is a part of the total defense, and of course the long-term plan also for the Norwegian defense is very instrumental here, and a lot of money will go into that sector. But that is very important also to think the society as a whole, not only the defense system, but the defense is also very highly reliant on rest of the society and the civilian part of the society. So it's very important to look at things in a context and together. So, but for electronic communications, this is our most important task.
Thank you very much.
If you're not into the technical solution, I think Christian and Björn here is having a very good point in the fact that when it comes to the total defense, it's very easy to think about the physical parts, the roads, water, and everything. But we have to see behind those physical parts. We have to have a discussion on a political level to raise awareness about the importance of PNT services in the total defense narrative or perspective. And I really don't see that we are there today, because it's very a physical discussion. Much, I think, but as Christian said, we cannot do anything if we are not addressing this. And the outreach from Jammertest, I think it's very important to get awareness about the fact that you don't have any roads if we don't have, so to have the PNT services. I think that they are making a very good point on that topic.
I know that you want a word, but who wants to go last?
Just a short remark in terms of resilience. The current GNSS systems, they're based on the principle of GPS with 24, 26 operational satellites. That in itself creates some vulnerabilities, because you are really reliant on those. What is going on now is looking how this can be extended in terms of space-based satellite navigation and PNT to LEO PNT, low Earth orbit. This is more complex because it will involve many more satellites, but it is now being demonstrated, and the decision was being made just last week in terms of launching the first demonstrator in that. So this brings forward something that is happening in general, that more engagement in low Earth orbit, which involves many more satellites, both in communication but also in PNT. So this is probably the future, not LEO in itself, by itself, but jointly with the other satellite systems. Important development.
I'd like to connect the dots between Jammertest and total defense, because the main factor, or the common factor between risk mitigation or strategies or action plans and everything, is knowledge. And the sandbox of Jammertest enables us to get the knowledge that we need, that will provide two certain issues. That is, the risk management is actually knowledge-based and not impression or hypothesis-based. And the lack of utilization of possibilities is also based on knowledge, based on that this is a road that you won't go up, and that is a road that is actually feasible. And that requires knowledge. It requires the collaboration between government agencies, between the industry, in an environment that is actually a sandbox environment. We can play, we can be motivated, we can be inspired, and we can do it without it actually having an effect on the current operations.
Unless you live in Blake, but that's okay. Yeah. Well, thank you very much for your insights. I'd like also to point out how excellent our professionals are in the PNT domain and that we're accurate to the minute on the schedule. So if we could get a round of applause for our panelists. Thank you very much. Next, I have the pleasure of calling up a couple of the people who help conduct the mischief at Jammertest. So now we have a presentation by Anders Rodningsby and Harold Hockland. Anders Rodningsby is currently a senior scientist at the Norwegian Defence Research Establishment with research interest in target tracking and navigation, especially focusing on satellite-based navigation and navigation warfare. He is one of the parties responsible for the generation of the various attack signals provided to Jammertest participants. Harold Hockland is the chief engineer responsible for time and frequency metrology at the Norwegian Metrology Service, but to us, he is known as Norway's Time Lord. If you ask him what time it is, you risk getting a very complicated but very accurate answer. So Harold and his frequent co-conspirator Thomas are responsible for both providing precise time references available at Jammertest, but also manufacturing the malicious spoofing and time offset attacks. We are lucky that these guys work on the side of good with us, but we get to benefit from their malicious thoughts at the activity. So let me just pull up the presentation and then give the floor over to them. Are you first, Anders?
Yes.
Okay. So there you go. You can see presenter view
Oh,
and
yeah.
then what everybody else sees.
Thank you, Aiden. So I'm Anders Rodningsby from the FFI, or Norwegian Defence Research Establishment, and as Aiden said, I will, together with Harald, try to give you an impression of what to expect at Jammertest this year, 2025. So here we see a bunch of happy people. Of course, they are tired. They've been working a whole week. I tried to count them. It's about 220 people, so it's a lot of people. We can also see that the weather is really nice up in Andøya. We have ordered the same weather for this year. We have ordered the same waffles. Actually, to be sure that the weather is nice as it looks like, if you look at Harald, he's wearing a shorts. And he was wearing a shorts the whole week, right? So hopefully this will be the same this year. We also see that we had a good variety of participants from the industry, from the research, and also from the government. So what to expect at this year's Jammertest? For those of you that participated last year, we're going to have the same test areas, and we're going to have almost the same transmission plan. We have, during the application process, got some comments or suggestions for improvements from all the different participants, and we're going to go through them and see what we can incorporate. Of course, we already have a lot of tests. Some of you will probably say that we have too many tests. We have not that long breaks between each test, and some people want to have longer breaks. So we need to find a kind of a balance between all these wishes. I think the main upgrade for this year will be that we're going to get support from the Finnish Defence Forces. So FFI has asked our colleagues in Finland to support us with a vehicle that can do transmissions. So that will be a good help for having jamming and hopefully spoofing meekling from different directions, and also to have more complex mobile spoofing. We're going to see all domain testing. We're going to see there's possibility to do testing at this out in the sea, at maritime domain, at land, air, cyber, and also space. And also, I assume that you all are expecting jamming, spoofing, and beaconing. If you're not doing that, then you're going to have problems. So I'm going to take some minutes to talk about what is jamming, spoofing, and beaconing. So this is the situation that we all would like it to be. We have signals, at least enough satellites, no disturbances, and we're going to get our true position and time. The first attack is what we call jamming. Then we need a transmitter, which is sending a jamming signal. This signal has to be powerful. It has to overpower the true signals so that the receiver under attack will not be able to find its own position and time. And of course, these signals has to be in the same frequency areas as the GNSS signals. Or else it could be whatever you want to transmit, any kind of noise, but you could also do it more smart. And in the case of having this high power jammer signal, then you will end up with no position, or sometimes also an unstable position. And probably the last letter one, the unstable position, is the most dangerous, because the position will probably wander around, it can jump, and it could look like our next attack, which is called spoofing. So spoofing, again, you need a transmitter sending a spoofing signal. This signal has to be built up in the same way as the GNSS signals, but with a purpose. And the purpose is to move the true position to a different location, and also probably to move the time. So if the spoofing attack is successful, then the position will be going to a spoofed position, and probably also the time will be a different time. So the final or the third concept is beaconing. For the receiver, it might look like spoofing, but the concept of beaconing is different. In this case, you need a transmitter, and also you need a receiver. The receiver receives the true signals. You can note that it also captures the encrypted signals, authenticated signals, every signals. And then these received signals are transmitted to the transmitter, which again retransmit those signals to the receiver under attack. So it's kind of a retransmitting system. So what happens? The true position is lost, and it moves up to where the signal was received in the first place. That means the position you want to spoof to has to be the receiver in the beaconing setup. And also the time will jump back to when the signal was received at this beaconing receiver in the first place. So it kind of depends on the whole delay in this system from the receiver to the transmitter, and the distance from the transmitter to the true position. So that was the 3 attacks that we're gonna perform. We performed it last year, and we're gonna do it this year also. Then this is I think this is the most shown picture from Jammertest, so it's well known. From the top here, you see the most powerful jammer, can transmit up to 200 watts ERP, and it kind of blow out these signals over the whole area, out on the sea and all to the small community called Bleik, where we have our main test area. And most people will be located in the community house at Bleik there. So this is, from the picture, this is test area 1. But we also have more test areas. We have the test area 2 at Grunnvatn, and the 3rd test area where we're going to do motorcades located between Stave and Nordmela. And also at Stave, we're going to have a community house where people can get food and get served on different things. You are free to go between all these test areas, 1, 2, and 3. The 4th test area, which I haven't put a number on, is the airport. And we're going to have testing at the airport for 1 day throughout the week. And that's only for the invited participants having an airplane or a helicopter. So for these 3 test areas, we can look at the main plan, which is very similar to last year. If you start looking at test area 1 on Monday, we're going to do high power stationary jamming, and we're going to do or plan to do long time high power jamming in the evening. Hopefully we will be able to do a 2-hour block jamming from the top of the mountain, and then a 2-hour block jamming from lower level. So that it's possible to compare signals coming from a high elevation and from the ground. On Tuesday, we're going to do meconing and high power unintentional RFI. That means we're going to take a signal and sweep it through all through the GNSS bands, so that we can see the differences if the signal is emitted inside the band or out of band. And on Wednesday and Thursday, we're going to do spoofing from the community house, from Blake. Spoofing mainly positioning on Wednesday and timing on Tuesday. And Friday is a kind of a reserved day that we can do repetitions, we can do variations of a previous test, and if you have some special attack, then we can probably try to manage that. Test area 2 is closed on Friday, and it's not determined what to do at test area 3. If you now look at test area 2, which is at Grunnvatn, we're going to do low power stationary jamming on Monday. And Tuesday, we're going to do multi-jammer scenarios. That means we're going to jam from different directions. And again, on Wednesday, we're going to combine this multi-jammer with a different direction with spoofing. And on test area 3, we're going to do motorcades with low power jammers. The big thing here is that the whole Thursday is reserved for mobile spoofing. So I will come back to those test area 2 and 3. But before that, we can look at how is the signal propagation. This is a simulated plot when we do maximum power from all our 3 locations, and not 3, actually 4. We have the airport also. So what we see, this is a plot showing what you call the jamming to signal ratio. Of course, the redder it is, the worse. And this is a level for all receivers located 5 feet above ground, so like a handheld receiver. So we see like the airport jamming will be affected. We're going to point in this direction. We have this is the main or high power jammer, and then we have location 2 and 3. So this is something we had to do to get the clearance from the right authorities. If we go up to 40,000 feet in the air, the power is or the coverage is much bigger. So this is most important for airplanes, helicopters. If they want to go in the area, they can try to see what areas will be affected, what will not be. Then this is test area 2 at Grunnvatn. We're going to use these handheld jammers. We have a quite big variety of such jammers, and those jammers will be used both at area 2 and at area 3. So you have to share them between those areas. If you look at test area 3, they have kind of made some specified positions so that you can put jammers in from 3 different directions, affecting the center. So you can jam from this direction, from this, and from the top, and from different distances. So that's what we call the multi-jammer scenario. At Wednesday, we plan also to have, in addition to the small jammers, we're going to have a car coming in. This is a mobile spoofer. So we're going to combine spoofing and jammers. We have not decided exactly how the test will be, but that's what we plan to do. And these things are relevant for drones. You can have drones in this area. You can test SERPAs, advanced anti-jam antennas. And you can also come here with your cars to do testing with your car. This time we're also going to have a bit more power by using directional antennas pointing in these 3 directions to the center. Then at the third area, we're going to do the motorcades. We're going to use the low power jammers. And as I said, we're going to have reserved a full day, the Thursday, for mobile spoofing. There will be some restrictions on how many cars we can have in this motorcade due to the range of how long we can affect. Of course, we can extend the power, but we don't want to extend it too much. So maybe 5-6 cars in front of the spoofer and maybe 5-6 cars behind the spoofer is possible. And this also shows where the motorcade will start on the top of Stave, where we have the community house. And then you can go down to the intersection of this small road here. It's intersecting the 7702, and you can go back and forth. And by that, I think I'm going to leave the floor to Harald.
Thank you, Anders. I'll say a few more words about test area 1, the main test site. No, it's on now. Okay, good. So what you see is the picture of the Blake Community House, and you even see the antennas for the FM radio, but also for the spoofing and jamming signals transmitted from the Blake Community House. So what we offer there is the opportunity to install fixed equipment and also to get access to undisturbed reference timing and to a shared feed of GNSS RF signal. Okay, and this is just a schematic of the shared RF feed from that we set up last year. And it was used by some, and it can be used by more people if they know about it. So it's at least an easy way to not having to bring everything to Andøya to test the equipment. One can hook up to this shared feed. Then this is a map of the Blake Community House, or the Jammertest headquarter, or we could call it timing lab, spoofing lab. So we try to expand, and we've expanded over the iterations of Jammertest the type of services we share. So one thing is we have the shared GNSS feed. We also offer reference signals, timing signals in terms of pulse signal or stable and accurate 10 megahertz signal. And last year we also offered access to the precision time protocol White Rabbit servers. And to make this as useful as possible for test participants, and in particular with timing applications in mind, we also last year offered, at least to a few users, access to our undisturbed GNSS RF feed that we use. It's very useful for creating the spoofing signals. So if you're curious about what we actually transmitted in terms of interference scenarios last year, you can go to the Jammertest 2024 test documents, and they're structured in terms of a test catalog, which is a grouped list of different kinds of GNSS interference scenarios. And this is just an excerpt of the group under the heading Incoherent Time Spoofing from Stationary Spoofer Using Synthetic Ephemerides. There should be an explanation about what this means, and you see there are all kinds of sub-varieties of this type of interference attack. Of course, we don't do all the attacks, so depending on wishes and the capacity and so on, we actually make a subset of the cataloged tests that we put into the plan of what's actually going to be transmitted. So that's the transmission plan. And then we also log what is actually done, and including various kinds of mishaps and things that were not exactly as specified in the plan and the test documents. So these are all available, and the test documents are machine readable as far as we manage to help actually automated data collection and analysis. So that's a good resource if you're curious about what to expect in 2025. You can expect much what we did in 2024, and you find quite a lot of detail in these test documents. So what do you expect, or what do organizers expect from test participants in 2025? Of course, we expect that they contribute to the informal, friendly, collaborating atmosphere at Jammertest. But what we really should emphasize is that Jammertest was organized to provide a test arena so that no unsafe systems were put into use. And really what we want to see are improvements. And we know we expose a lot of areas for improvement. We know. Even if participants are not obliged to tell anyone about it, we know. And of course, we have a bunch of end user customers that are happy to report what they see. So this is one end user putting up a very visible large clock display, and this is 2 shots from the large time jump, 2 different kinds of large time jump spoofing last year. And you see that the truth is on the top, the green one. What's shown here in blue are the GNSS clock cards that actually swallowed the false GPS and GNSS signals and just happily jumped a few years back or forward in time. This is not something we want to see from this, especially from repeat participants. There must be a way to fix this with a clear instruction on how can you configure your GNSS device, not to just simply follow whatever it gets. So, this is a clear expectation. By providing this test environment, we should also see improvements. And I'll end with showing a small video of devices tested by the Norwegian Coastal Administration with different kinds of generations of navigation devices and with different types of integration with inertial systems. The ground truth here is actually standing still. And the blue one is following the spoofed path. And what the other ones are doing, some are taking a detour to Germany. We don't know why. So clearly this is all about having robust logic and robust sensor integration into sensors that actually should tell you you're standing still. So with that said, at jammertest.no you will find the test catalog and updated information. And welcome for those of you who who have applied for participation and get the acceptance soon. Welcome to Jammertest in Andøya, September 15th to 19th.
I would like to ask Anders to come back up because we have time for a question or two. And the first question I want to ask both of you is whether or not you think there's a special place in navigation device hell, not for devices that are deceived by your spoofing, but for ones which then accept it, but then refuse to trust reality afterwards. Like if they're going to accept it one way, why do they not accept it the other way? Can you comment on that a little, or what you might be doing about that? Do you just bring a hammer and take care of them when you find them?
Do you want to comment?
If you don't want to talk about that, we can talk about how many lawnmowers, children, and cats you put on top of them.
No, but clearly, some of these things should actually be known in advance. You don't have to test because you know there's no skepticism built into your equipment. And that's been for a long time with time servers. The only thing you need to get it working as a time server is to set the network parameters. You don't have to do anything about the timing because it's automatically taken care of by the GPS antenna. Which means anything that comes through the GPS antenna is taken as good stuff. And when good stuff is bad stuff, then bad stuff comes out of your time server. So that's the type of simple truth about reality that should actually be codified into these systems.
Anything to add to that?
I think that it's one point is that we should be more advanced users when we specify what kind of systems we want to have, because sometimes often we just order a system and we don't actually know specify that it's for example systems that are using GNSS and inertial navigation systems. We say that we need inertial and we need GNSS, and then we don't say anything more. And what happens, as we see at Jammertest, GNSS works okay when things are good, and INSS works very good when you know that GNSS are affected. But the problem is that the transmission phase between starting of jamming and when the GNSS measurement starts to be strange, and probably the inertial system doesn't get that information, that don't use those GPS now because we cannot believe them. So if the customers hasn't specified how the fusion of different sensors should be, then we can get very different or strange effects.
And just to clarify on that point, that animation you showed, those were static users. Yeah. ZUPs should work when static.
Yeah.
All right. Well, I want to say thank you very much for presenting, and I look forward to seeing what you guys come up with, because it's been devious in past years. I've had a couple of receivers go to that special place where they refuse to come back after. Thank you. Next, we have the pleasure of hearing from Pierluigi Mancini from ESA's Navisp programs. Specializing in electrical engineering, he initially graduated with honors from Naples University, then was awarded the master's thesis from the Polytechnic Institute of New York. Could you load up your presentation? Let me just bring up the folder here. I'm sorry, I'm being a bad master of ceremonies. I should have had this loaded for you already. There we go. And if we switch that into presentation mode. Good. I'm sorry, my phone locked during that moment, so now I need to finish reading the introduction. He has more than 30 years' experience in the space sector, where after several years of research and development activities in the spaceborne radar domain, he was involved in the definition and implementation of several ESA missions, such as ERS, ENVISAT, small GEOSAT, as well as some key strategic developments in the field of space-based applications. He has been responsible for strategy and feasibility studies division of ESA's Directorate of Telecommunications and Integrated Applications, and in this capacity he conceptualized the actual creation of the Integrated Applications Program. He is now heading the Navisp program, which aims to further foster European industries succeeding in the highly competitive and rapidly evolving global market for satellite navigation, and more broadly, position, navigation, timing technologies and services, while supporting ESA member states in enhancing their national objectives, capabilities in the sector. Thank you very much for coming all this way to us today.
Thank you. Good morning to everybody. First of all, allow me to thank the Norwegian Space Agency to give us the possibility to present you this program. You have heard today already a lot of information about what is the problem behind, but allow me to say it's about occupying space in a bandwidth. People have been working on GNSS from decades, and of course smarter people use better the bandwidth. Nevertheless, more you go to the edge of the bandwidth, because you believe via Kramer-Rao type of ratio you will use better the bandwidth, more you are vulnerable. The Ligado effect happening in the States was the beginning of the concern. So everybody is trying to sniff around in different bandwidth, and the reality is, if it's harmful in any case, you can do it on purpose or not on purpose. but the issue is how we can handle it and which instrument in Europe we have to support it. I'm very happy to give the possibility to present you this opportunity. It is a program in which your country has been strongly interested from the onset. I will tell you some of the identity of this program, what we are trying to do with this program, and what is overall the ambition. You will have also another presentation in detail from my colleague Stefano about the result of what we have done in the Jammertest last year with ESA. So starting about Navisp, essentially what we have, we all know SatNav is a strategic sector. There is a lot of work created via SatNav. It's not the case that the American, when they started with GNSS, with the uncontainment of DoD, they always say, yes, it's about actually have a priority for our defense, but it's not only this. It's as well to leverage professional application and consumer application. And this is market. Just to give a number, the consumer market is completely out of the business of European. This is coming from the beginning because there are companies like Broadcom and Qualcomm that systematically are developing chipset and they are driving all the consumer. We have on the professional market opportunity, mainly on the transport, mainly as well in other type of application. But we are aware of the fact that European are still very low in terms of market development for this application. And of course, protect toughness augment, what people were talking here, how to protect that, it's a market per se. Alternative PNT is a great opportunity for a lot of companies to develop terminal, different sensor, and to make sure we can provide this important information. How important is information for the society? I mean, at the beginning we had the panel, people were talking, yes, in 5G, 6G, the timing is provided as synchronization. They were talking milliseconds by GPS, Galileo, you name it. Yes, it's true, but there are a lot of different infrastructure. They are de facto based on GNSS. It is that especially timing is an invisible information that is used systematically. Financial service, insurance company, energy sector. And we had several studies done in Europe in which, as a matter of fact, just for the UK case, 1 day without timing information will cost to the UK economy £1 billion per day. And this just tells you what is the impact. So when people say, we have to take care, it's not for the fun. It's not about the fun, it's about business. If you lose this type of information, is fundamental. So everything we are doing, and you are doing, like the Jammertest, to understand better how to mitigate this risk is fundamental. Two cases that are fundamental for us in terms of application, here I'm exposing some of the things, of course, as I say, is finance and energy. Finance is fast transition, you need to timestamp, you need to make sure things are correctly done. You need very high accuracy. Even GPS sometimes will not be capable of Galileo to provide it. As a matter of fact, a lot of financial institutions are providing information like the metrology office via optics. And today I heard of applications like White Rabbit that will enhance the security, giving better blinking eyes in this type of protocol, and this is due about business. It's not only for the sake to provide high accuracy timing information, a high availability timing information, it's because they rely a lot on network and a lot of infrastructure on this information. Energy is the same. So it's becoming de facto an essential fundamental information for all society. We don't talk in general only GNSS because, as a matter of fact, the concern of the Jammertest is about satellite vulnerability, is correct. The satellite signal, especially from MEO, is deeply buried in the noise. We kick it out from the noise via CDMA type of algorithm. We will have obviously LEO PNT that will help as much because going lower you will have a higher signal to noise ratio, but nevertheless you will always be vulnerable. You will be vulnerable in many cases. Nevertheless, we are aware of the fact that we are facing a world in which essentially, is a matter of years, everybody would like to have PNT information. It's de facto becoming a universal services. No matter how you receive it, satellite, grand infrastructure, you name it, it will become a universal service. But it will need availability, integrity. Today I heard how is the concern about diagnosis, is correct. but not only from vulnerability man-made, as like solar storm and so on. These I will apply in a lot of other type of application. Integrity will be fundamental. You will not have autonomous transport if you cannot ensure integrity, and this is hell of a lot of work. A GNSS is a small part of the answer, and as a matter of fact, we have to think overall also PNT as the answer, so adding sensor from on-ground infrastructure as well. It was presented before, and I apologize if I'm repeating, how much is sensible certain region. We don't need to know why, but you can see, for instance, here the latest status we have put on the GNSS interference axis. This is amazing. It's amazing to tell you how today we are having important impact, for instance, in the aeronautic sector, and we will have more and more this impact. This is going to be something that we have to get used to it, and we have to have measures to mitigate this type of problem. And of course, this is a key concern for all of us. And in this frame, the Jammertest is fundamental because it allowed us to get better knowledge. I like to stress the fact on microning, on spoofing, interference, jamming, we know just a bit of what to do in order to mitigate. We are at the beginning of this. A lot will be done with active antenna, even on miniaturized one, but as well on alternative PNT. We are seeing the British that are quite advanced in this sector via the PNT office. They are fostering the ILORAN that was originally set up for maritime application, but now they are actually putting it in order to use terrestrial application. And the interesting part of it, they are also working intensely to miniaturize antenna, because in low frequency you will expect a big antenna, something you cannot have. I will be unfair to not say a very important development that due to the Norwegian Space Agency has been set up. We are working intensely for the maritime application with the VDS. We intend to put together with the effort of the Norwegian authority, but as well of a combination of company and academia coming not only from Norway but from Germany and UK, a VDS set of satellite in order to mitigate the risk to having different type of information. If you have VDS, is a kind of advanced SAT-IS that will allow on low frequency providing navigation information independently from GPS. This is key, and this could not have been done without the support from the company, from the national agency, and this will allow for high latitude also to have better knowledge also of the ionosphere, scintillation, something that we are very strong in modeling in different type of latitude. But up here, I would say up there, but I'm here, up here, it's as a matter of fact fundamental. And this we are working a lot of alternative. I call it, some people call it complementary PNT, alternative PNT, is what essentially the American call protect, toughness, augment. It's a different way to augment. This is what I was stressing before. As a matter of fact, this is just to tell you that on the right you can see the study that has been done in UK, and we have done in detail also this type of impact analysis at European level, and this tells you the impact of what I was saying of £1 billion and the sector that are affected per day. So this is fundamentally, so this is at the heart of our economy. If we have no timing, we are really in trouble. Why PNT is important for us, and why the Norwegian Space Agency together with other space agencies are supporting this type of sector. Now if you see on the top, you see the overall mainstream in terms of funding that you can actually, revenue that you can actually see for different sectors. And you will realize that 65% of it is de facto the GNSS. So there is not a single part of the world that is not involved in PNT and GNSS. It's not possible. It's the biggest driving market. Telecommunication is going down, and Earth observation is de facto non-existing. There is practically no commercial market yet. So it's obvious that everything that we put in place to reinforce, to increase the resilience of this type of information is fundamental. And this is the reason why we think it's very important for us to operate. Not only the sector is very important, but also I have to stress the Europeans are flying on 23% only. Now, as you will see on the next slide, what does it mean 23%, 22, 23, how you calculate? Typically in any ICT sector, The Europeans are flying around 33%. In this sector, we are around 23%. So you realize that if we could achieve the 33% of this market, we will create much more jobs, we will have a much more fertile economy in Europe in this sector. Needless to say, the 90% of this market is open. What does it mean? It's a market that is not captive. That is a very good thing, but it's a big risk. When a market is open, you can go in other country, in other region of the world, and acquire opportunity, like for instance we have done in Australia with advanced diagnosis type of application. But you can also be a threat, because you can have different type of provider from different regions of the world coming in Europe and providing it. So this is what is the ambition here, is to try to get a bigger part of this cake and to try to make sure that Europeans play a bigger role, keeping in mind the consumer market is something we are really surfing, because it's completely in the hand of different regions. So the PNT opportunity, if you put together all the opportunity, when you talk of PNT, there is a GNSS part, the things that all of us are aware that you get from ESPA every year, and is up on the left. But as a matter of fact, you have much more sector, and this is interesting, therefore we talk of PNT. Look down on the left, you will realize what is the automotive, the ADAS type, depending on the level. And you see how the market perspective are huge. If you see on the right, on the top, you actually see the jamming market, what possibly people are trying to counterattack when you do Jammertest, but there is a market there. So there is a lot of people are working on that. They are trying to look at the system that can actually increase the resilience, but as well there are different type of purpose also for jamming data. So it's a market per se. Last but not least, down on the right, you will see the indoor. People underestimate how important is the indoor application. People will not want to operate to have a PNT information that is not seamless. You go outdoor, you enter indoor, you don't have any more this type of information. It's not possible. So there is a huge market there, ultra-wideband, RFID, you name it, that is nothing to do with satellite, but need to be well linked to the satellite information. You have to have a kind of breaking the digital divide in PNT, having a universal service wherever you are. And this will be the future. You will have insurance services based on the fact you have an accident. They want timestamp where you got the accident. They want to make sure where you were when you got after, you name it. And this has a lot of forensic evidence importance. So what is Navisp? Navisp is the commercial legs of what we are trying to do. It's an intergovernmental program, so it's totally different of what we do together with the Commission and our colleague of ESPA. And it's based on the interests of our member state to support dedicated action for their own interest. I would not be surprised that we would see activity or relevance for the jamming test based on funding coming from Navisp, on the base that, of course, the Norwegian Space Agency is interested to fertilize it, to foster this activity in this frame. We are looking for several types of activity in protect, toughness, armament. This is what you can expect is the main market as well. We are looking at satellite opportunity. I will give you some example later on. But essentially, the most important thing, we are hinging the program with market owner. We don't believe to enter in market in which we cannot understand, be closer to market owner. One of the examples, for instance, we are working intensely with Volvo. We are working intensely with Grimaldi, the big ship tanker owner that actually is transporting all over the world. They want to automatize their berthing and to make sure the operational cost of their berthing is cheaper. So less people using more multifunction of sensor in order to make sure that you have better parking, berthing, as they say, in faster time. This is money for them. Example of what we are doing. The first of all, I need to give it again because for us we are proud to be here. To say we're starting with an activity called icing. I will call it a kind of demonstrator. And now we are in a bigger activity. I see here some of the key actors of it. That is called MAPS. This is very ambitious activity. He will eventually put 4 satellites, I believe, on orbit in order to make sure he can provide on high latitude VDS services, and the ambition is to provide these VDS services independent from GPS, so increase the robustness for navigation in that area. It will not only be satellite, one of the actor area will be also terrestrial, and we will make sure that all the routing between the terrestrial and the satellite part will be put in place, also exploiting dedicated algorithms that have been developed in different parts of Europe, namely in UK as well. So put it together, this expertise, you should leverage new services. They have co-funded this activity, that is important, so they have a commercial ambition as well to provide these services for different type of activity. And as you know, also in the future, transport in the Arctic region and so on will be more and more important. Have this kind of alternative capability will increase the resilience and the safety for this. So we are delighted. But it's not only this. We have other activity. I give you some example. For the sake of truth, we are more than 350 activity at today running, and we have invested quite a lot of money already. And I will give you some details. So we have a Dover and Perrin that are activities that are used by UK, so dedicated satellite in order to have a possibility of selling PNT as a byproduct for different capability, as well for their security services. And also we are working on quantum time transfer using commercial company like Viasat and Cryosat in parallel in order to provide quantum information on timing with high accuracy and in a resilient way. So this is some of the things we are exploring, but it's not all this. You can see why we are working with different partnerships. I mentioned you Grimaldi, I mentioned you Volvo, but I mentioned you another thing that maybe for you is fundamental, EIA. We are working with the International Atomic Energy Agency. They have a set of more than 4,000 inspectors going in area in order to acquire forensic evidence for Non-Proliferation Act verification. So they have to make sure that the information they bring back, they have to be assessed, have evidence that to be integral. And of course they want to join forces with us in order to make sure that we can help them. This is another way of partnership with an important element, and is about increasing the resilience of this information. We are fostering different type also of other type of key market owner. You have here some written logistic like Hermes, precision farming John Deere, MPL on the timing sector. We are working with them. They want to provide information for metrology office with very high quality clocks, and they want to distribute it. We are talking now market on another second type of information. This is what is their ambition. And in order to provide this with accuracy and integrity that is required, we are engine forces with them. U-Blocks, I don't need to tell you, is one of the main worker of high precision type of information using specifically microchips, and is a foundry, a seamless foundry in Switzerland. We are working with Bosch, Valeo, Rover, Jaguar Land Rover, and Vodafone. So we have a lot of opportunity over stimulating. Where to hinge the program to market owner? Because this program is not ESA-centric. It's not about us to see what is the business in automotive. It's to make sure that we can help this company with their funding and our support to succeed in their business. Some of the number I can give you, there are much more, but I really don't want to bother. Today we got extra subscription by different country. We are at today around 150 million, but we are only simply requesting 110 million for the next ministry at the end of the year. I don't think, and we don't believe that the program is success according how much money received, but the problem is a success respective of the pertinence of this action. And we are delighted to say that so far we have received only positive support from all the member states. We did also an economic impact study, is fundamental, an external instrument to allow to see what is the return of this. And we had for every 1 million invested in Navisp, a return of investment, a return of 1.8, a calculation in terms of direct return of investment around 56%. But I would like to give you two numbers that are key for you. We have been working on more than 350 activities. But what is interesting is more than the half is not space company. This demonstrating that the solution is nothing to do with the satellite per se, it's PNT. We have stretched the boundary of the action of ESA and company that even didn't know us, and a lot of SME. We are not surprised that the companies stemming from university, postdoc group are fundamental for this. So the last slide for this is we are preparing, as I say, the phase 4. We have received already positive comment. We are now finalizing the small implementing rules and declaration that will be hopefully close at the next PBNAP. And we will have a program that is agile and fast and hopefully beneficial for all your concern. Thank you for your attention.
Well, don't go anywhere just yet. I want to say thank you very much for coming to present to us. And I know that there are several people in this room who are going to be very excited by some of the things they've seen on your slides, including but not limited to picosecond level synchronization to satellites. They might want to talk to you about it. The good news is that now it's time for lunch, so there will be an opportunity to ask questions. I might want to give you a 1-minute head start so you can get your food without getting disrupted. But thank you very much, and can we give him another hand? The technical program will resume at 12:30 sharp. For those of us who are joining us remotely, the room will have just the banner up and showing, but everybody please be back quickly for 12:30 because we want to get started as soon as possible then. Thank you very much.
I think you can start talking.
Yeah. I'll introduce you and then. Hello, everybody. Welcome back. We're ready to get started again. Our next presenter has joined us from Ireland, and unfortunately, due to my unclear instructions, he booked an early flight out. So we have to help him get out of here after his presentation as quickly as possible. Cillian O'Driscoll has been working in the field of wireless navigation and timing since 2001. Since 2014, he has been working as an independent consultant, supporting industry, agencies, and academia in the analysis, development, and implementation of wireless timing and navigation systems. I've had the pleasure of knowing Cillian since, I believe, 2006 we first met, or possibly 7.
6.
So it's a good thing you don't have any time to tell them any stories, but please take over.
Thanks, Aidan. And yeah, I must apologize to all the other speakers that I'm not staying, but my flight is at 3 p.m., so I'm under a little bit of time pressure, which is probably appropriate given the topic. So yes, I'm here to talk about the Fugro Atomicron standalone time service, which is a sub-microsecond GNSS independent time transfer service from Fugro. So I will, through this talk, just give a quick outline of what ASTS, what it is, what the goals are, and how it works, and then talk about some testing that was done at Jammertest 2024, and then talk about plans for attending Jammertest this year. And I will try to resist the urge to talk as quickly as humanly possible. So Aidan, give me a kick if I go too fast. So first of all, the ASTS, the Atomicron Standalone Time Service. The concept of this is that it's a one-way satellite time transfer service using existing L-band signals from Inmarsat geosatellites and targeting a stationary end user. So with that, a geostationary satellite and a stationary end user, we can use these directional antennas. How this works is that there's a correction message that's broadcast on the Fugro L-band data stream, and this correction message is computed using a network of reference stations that observe the signal. And the goal of this is to provide this PTP, precise time protocol, primary reference source, or PRS, to give this capability to end users in a GNSS independent way. That's the goal. As you'll see, we maybe talk about this as being locally GNSS independent, but I'll talk about that later. It refers back a lot to what the panel were talking about. But the goal here is that this is traceable to UTC. We get this time transfer without GNSS. So here we have a little card where this is implemented, the entire service, tracking the signals, extracting the corrections, computing the time, and steering the clock. So the operational concept here is to use these dedicated messages on an existing Fugro L-band communications channel. So through this channel, we transmit these corrections, which consist of a time of transmission marker, the carrier frequency, carrier phase information, and orbit parameters. And these are transmitted down to the end users. Then the end users take this, tracking the signals. They use this patent-pending algorithm to obtain estimates of the local clock offset at the end user site. And the goal here is less than 100 nanoseconds time error and better than 1 part per billion frequency error for that clock. So the result of all of this is a one-way satellite time transfer using this dedicated signal that's locally GNSS independent and traceable to UTC-K. So you can see in this kind of cartoon here, we have the geosatellite that's transmitting the messages as normal. This is observed on the ground by a reference station that's linked to UTC-K, which creates the messaging information, which is uplinked and then received by the end user, which uses this information to compute the time offset. So at the end user site, we have this directional antenna, first of all. And what else is needed in order to provide the service? Well, there's a narrowband SAW filter. I think that's important for the type of work that we're doing here, because the L-band signal is quite narrowband. It's a few kilohertz. And that allows us to put a very tight narrowband SAW filter on there to reject out-of-band emissions, so like GPS jamming and spoofing, for example. That's the goal. In addition to this, then we have the controllable oscillator, and the architecture is shown here. So the oscillator, including a 10 megahertz reference and a PPS output, is connected to an RF front end from which we collect time-stamped IQ samples, process the signals to estimate the timing of the signal, get the correction messages. From that, we can estimate the offset between our PPS and our clock and UTC time, and steer the clock so that we have this reference. And again, all of this locally here is completely independent of GNSS. There's no GNSS receiver involved in this circuitry in any way. The current status of this is that we have the service available right now on 2 satellites, one over the Europe, Middle East and Africa, and that one is traceable to UTC PTB in Germany, and another service on a satellite over the Americas traceable to UTC NIST. And the plan is to expand this into the Asia-Pacific region and have a total of 6 beams. Right now we have 2 beams, but to have 6 with three regions and full redundancy in the both regions. And in order to process this, obviously it requires a subscription to receive the messages, then the user equipment to decode those messages and to compute the offsets, and some mechanization to drive the clock. I want to give a quick overview of the kind of performance that's possible with this. This is some post-processing performance that we did earlier this year. Back in January. This is 3.5 days. And what we're looking at here is some data that we collected at Cape Verde, a site there. There were a number of reference sites in the Europe, Middle East, and Africa region that were estimating the signal parameters across all those sites, feeding those together and computing the satellite orbits and time corrections and so on. In this case, this is post-processed, and it's a relatively quiet ionospheric day, but you can see the sort of performance that we get. This is 30 nanoseconds, plus or minus, over 3.5 days, with some variability at that site. So what in this case, I think at this point in time, we were using JV, Gaustadalléen, for the time source rather than PTB. But we also have another Fugro product, Atomicron, high accuracy service at the remote site to use as a reference. So the 0 baseline here is that high accuracy reference, which is significantly better than the performance that we're seeing here. So it's a good baseline. Okay, so that's the overview of the Atomicron standalone time service. Let's have a look at Jammertest now. It's nice to be the first presenting results because you're probably going to see pictures like this quite a lot over the next while, so it still looks a little bit fresh and original. The jammer, I think, is somewhere up there. I had a previous version of this where I had that circle on that antenna, but apparently that's not it. I haven't been there myself. But here we have the directional antenna, and this is pointing at the Inmarsat satellite that we're using for time transfer in this case. So back in September, we didn't actually have the signal on air, but we were, as in the correction messages weren't on air, but we're still tracking the signal and getting the timing from that. But this is a proof of concept where we're doing the time transfer from another site in southern Norway that was also tracking the signal and getting the timing correction messages over the internet at that point for that. So the goal here was to test, it's all very well to say that we're GNSS independent. The question is, how does that work in practice if we're testing this? So we wanted to see how well this performed, both in terms of tracking and extracting the measurements and in the time transfer capability in this configuration. So there's a lot happening in these slides. So I'm going to talk through this. This is the day 1 at Bleik. So what we're seeing here is over time, this is the course of the day on the x-axis. On top, what we're looking at is the time error from the ASTS output. So this is tracking the signal live, getting the corrections over the internet from the site in southern Norway, and then comparing the time that we get from that with the time provided by Gaustadalléen in the little house there in Bleik in the picture that Harald showed earlier. So again, this is over this time period. We're getting very good performance here because we've got a short baseline, let's say, between the reference site. But the point really is that during the course of the tracking, you can see these red shaded areas. Each red shaded area is one of the jamming tests during that day. So there are a couple of interesting things here. On the top, we have the timing error, and you can see the range there is, you can just about see 200 plus or minus 200 nanoseconds. On the bottom, this is the EBN0. We can see that we had some drops. This is the SNR per bit. It's sort of like a CN0 plot for this. But the key thing is that we have very stable tracking throughout. We do have one point here just before 3 p.m. where we have a dropout. This was a reset of the filter. And then the antenna got blocked. There's a problem with having the antenna where it was. And we'll see that that's a common problem that I think it was a vehicle parked in front of it. So the line of sight to the satellite was somewhat interrupted from that point on. But really the critical thing here was during this particular day of testing, which was really high-powered GNSS testing, jamming rather, we had very good continuous tracking with no real outages. On day 2, again, this is another day with lots of jamming. The same sort of plots. What we see at just around 10 a.m. was that we saw the SNRs dropping, so the antenna pointing was repositioned to better align with the satellite. You can see the EBN0 comes up, and we have a kind of, again, a reset of the filter. But in this case, again, we've got very good tracking. You can see the impact of the EBN0 improvement in the noise levels before and after the adjustment. And I think one of the more interesting things here is that during these two time periods, there was a swept beam that actually came through the L-band. So I think it went from 1545 and up. So while it's mostly GNSS jamming that we're looking at, we also had some jamming in L-band. And this causes the EBN0 to drop. We have some tracking problems, but you can see that the actual timing offset never goes above our 100 nanoseconds plus or minus that we're targeting. It has to be borne in mind that for this particular test, it's a swept beam. It actually goes through L-band very, very quickly. If you go back and look at the Jammertest website that Harold was talking about, you can see the details on that. But you can see that we're clearly, once the jamming is in band, obviously there's not much you can do about that. But when we have GNSS targeted jammers, we're able to track through those. We also looked at day 3 and 4, and these were the spoofing tests. And again, I think you saw this similar picture earlier in black. And we had some issues on these days. Primarily, again, we had issues with LOS blockages. So there were numerous dropouts. But also with the short distance to this antenna, there seemed to be quite a lot of power coming in band. So a lot of the time we were either blocked or jammed, and it was hard to judge. So this is kind of a lesson learned for next year, well, for this year, is to look at maintaining a bigger distance, because if we do receive this in-band jamming, it's better we're a bit further away and we can see as the power comes up where exactly the threshold is, for example, that can help us determine protection levels and all that sort of stuff. And obviously we want to have a better positioning of the antenna to avoid blockages as people and vehicles go past. So that's from 2024. For 2025, the planning obviously is to go back again. And really this is because Jammertest is the only place you can really test this sort of thing. You can put on your marketing material that we're GNSS independent, but until you go and you actually see what happens when you've got all this power in band. You know, we say that we want this to be GNSS independent, and people talked about this. There's so many dependencies in the chain. Who knows where your GNSS dependencies really are until you get out there and test this? It's impossible to say. So obviously for this year, we're planning for better mounting of the antenna to get more data during those meakening and spoofing days as well. And critically, this time we will have the full on-air system, so that this will be the live correction messages and true system performance under these jamming conditions. So that's the outline. So in summary, this service provides sub 100 nanoseconds timing with better than 1 part per billion frequency transfer with traceability to UTC-K. It's, as we say, locally GNSS independent. Unfortunately, we don't have a global Jammertest that we could use to test if the whole system end to end is completely GNSS independent, so it's maybe not possible to claim that. But we were able to track, even when GNSS is out, we can still track this, at least under many circumstances, and still get this sub 100 nanoseconds time. And finally, that yes, Jammertest provides this unique opportunity for us to test the resilience, but also to give us insight into how we can improve resilience or improve resilience against GNSS jamming and spoofing in the future. So with that, if I have some time for questions, I maybe didn't go quite as slowly as I hoped, but thank you very much.
Yeah, I don't think I can let you get away without answering a question about the signal characteristics, because coming from a GNSS background, getting 100 nanosecond synchronization might initially seem, okay, that's pretty good, not great, but pretty good. But then you have to remind us how little bandwidth you're using here, because you don't have a BPSK1 or BPSK10 signal.
No, it is a BPSK, but raised root cosine at 2 kilohertz. 2 kilohertz. Yeah. So it's a very, very narrow band signal, but again, given that we're stationary and we have a lot of filtering that we can do to apply to extract good quality time.
Because I would call that quite impressive spectral efficiency.
Yeah.
And then I guess you might want to correct me on this, but I don't think many applications are very resilient when the attacker can get within 4 meters. I think at that point you've lost already.
Yeah. Yeah,
so
no, that's true.
not
But
your
I
operating
think if we have more distance and we can see what kind of power levels, and I would be very interested in seeing the actual spectrum out of the spoofer, and potentially it's not the cleanest GNSS-only spectrum, but we don't know, so we'll be interested in seeing these things as well. But that's all for 2025 and see what results we can get.
Be careful about blaming the guys generating the spoofing. They are
No.
truly-
I mean, if they're putting something in band, then we need to deal with it.
Okay. Well, normally I would open it up to audience questions right now, but because Killian has a flight to reach, I say we just thank him and wish him safe travels. Thank you, Killian.
Thank you very much. Thanks, Aidan.
We're going to move ahead to Sherman Lowe's presentation a little bit early, just a little bit. So come on up, Sherman.
I need extra time anyways, so
Yeah, that's great.
I thank Killian for doing that.
We try to accommodate. Okay. You may have the podium.
Great.
And if you're going to point at anything, please use the laser pointer because then they can see it on the live stream.
Okay,
Yeah.
great.
So I'm just going to introduce you first, though. Sherman Lowe is a senior research engineer at the Stanford GPS Laboratory. He is also executive director of the Stanford Center for Position, Navigation, and Time at Stanford as an instructor. His research work focuses on navigation safety, security, and robustness. At Stanford, he was an associate investigator for the FAA evaluation of enhanced LORAN and alternative position, navigation, and timing systems for navigation, or APNT. He currently leads work examining GNSS resiliency, interference and spoofing detection and mitigation. He has over 170 conference, 30 journal, 19 magazine publications, and 10 issued U.S. patents. He is also a fellow of the Institute of Navigation and just finished his term as president. And just before I let you go, I also want to point out that this is also a distance record for attendance so far, because we just had Ireland. Now we have Stanford. Yeah, we're doing pretty well.
Thank you for having me here. I'm glad to have the extra time because it's really four short talks in one. And I'm going to go over a lot of the things and experiments that we ran at Jammertest, along with the University of Colorado, who we collaborate with. And so you can see all the different collaborators and students that worked on this item. So without further ado, these are the four things I'll talk about today. Again, I'm not going to go into a lot of details about them. Please grab me offline to ask me questions if something interests you. We did a couple different tests. So Colorado did a test of using crowdsourced smartphones to locate and detect the jammer and spoofer and to understand differences among smartphones. We brought several what we call low-cost monitors built on COTS, commercially off-the-shelf equipment, to provide infrastructure protection for key assets such as airports or intersections for autonomous vehicles, for example. We also looked at some user-side mitigation technology in terms of a dual polarization antenna, which allows us to both mitigate spoofing, interference, but also detect direction of arrival of spoofing and figure out that you have spoofing out there. And then we also did some work in looking at using ADS-B for interference detection. And we'll go through each one of them. We had these placed throughout different parts of the test. Let me use this virtual laser pointer, if I can. Is that showing up there? No, all right. Okay, I see it. There. All right, so we had 5 of these low-cost monitors, which for most days we spread throughout the whole city, town of Blake, and then in the test area we had our dual polarization antenna, and then at our house we had our ADS-B receiver that received the ADS-B equipment. And the smartphones were generally put out here, but we also use test area 2 for that as well. And so we'll go through each one of these individually, but in case you are tired after lunch and want to take a nap, this is all you need to know. This is our bottom line. Crowdsourced smartphones, we tested it and we demonstrated in real-time localization over the network. They all had SIM cards. Figure out where the interference source was using power difference of arrival. We also characterize a bit of the different smartphones because we had a non-homogeneous set of 15 smartphones. For the low-cost monitor, we used it to look at detection of jamming, which is pretty straightforward, and really high confidence detection of spoofing, and we'll talk about that. It turns out that these off-the-shelf receivers, these U-block receivers, had a lot of cross frequency aiding, which actually from Harold's standpoint, that's an improvement from year to year. But for our standpoint as a monitor, we don't want that because we want to see what's really happening, what should be happening. And so it made spoofing actually less observable. And so we're working on how to do that better for the next test. So that's our improvement that we're looking at. Dual polarization antenna will show just results of how it works and how it was able to locate directionality and where the spoofers are located. And then we're still working on processing a lot of other data from other experiments that we ran. But it was a great test to be able to run all these different experiments and collect data and then later process them for those things. So we'll start with the first one, which was the 911 smartphone. These are kind of examples of some of the smartphones that were used. We had a non-homogeneous set. These were all Android smartphones. Most people here probably know why we use them, but again, it's the most prevalent smartphone in the world, but more importantly, they've enabled what's known as GNSS raw measurements, so giving us a tool to have details about GNSS to provide this localization and detection capability. But every manufacturer implements it a little differently, so it's really important to understand how different phones and different chipsets operate. So that's kind of the issue there. Won't worry about the market share. And so there are two capabilities within these smartphones that we look at the most. One is AGC, automatic gain control, which really tells you how much energy is coming in. And then the other is CETA and NOT, which is basically the signal-to-noise ratio of the signal from each satellite that we're tracking. And so we can use that to differentiate between jamming and spoofing, because if more energy is coming in, it'll cause the AGC to drop, but it'll also cause your signal-noise ratio, your CETA and NOT, to drop. And so with jamming, they both drop together. But with spoofing, it's a fake signal that's trying to look like the real signal. So it's still more energy coming in, so the AGC will drop. But because it's looking like the real signal, it will not necessarily cause the CETA NOT, the signal-noise ratio, to drop. In fact, it might even cause it to rise. And so that difference in behavior will allow us to detect the difference between spoofing and jamming. And so the goals for the 2024 test was to kind of characterize these phones and then demonstrate a real-time localization with 15 Android smartphones. This is us in test area 2, which you heard about earlier from Anders. And we set up 15 phones there, and we're able to kind of try different things. We had four different types of smartphones: a Pixel 6, Pixel 9, Galaxy S24, and a Xiaomi Redmi K40, but 15 phones overall. But first, we also had them in the field to characterize them, and they do perform very differently. And so we'll give two examples. One is during the jamming day on Monday, and one is the Pixel, and we'll compare that with the S24. The Pixel performed what you expect. So it gave out positions even when you're jamming L1. It only lost positions when you're jamming. These are all dual frequency phones, so they all did L1, L5. It only lost positions when you did L5. Everything kind of behaved reasonably. The CETA NOT and the AGC behave like you expect under jamming. The S24 did not do that. It didn't, for a while, it only gave like a fixed position regardless of whether they're jamming or whether it was nominal. And then sometimes when they're jamming, it actually reported a higher CETA NOT. So there's some issues there. And so this really highlights the importance of understanding each chipset. And then also, again, this improvement that Harold was talking about, getting back to the manufacturers about these issues and having them resolve these issues so we can better use these phones. So the next thing I'll talk about is the localization test. In test area 2, we're allowed to take a jammer, walk around with it, set up our phones in different positions to try and locate it. Here's an example. These phones were all hooked up to the network, send the data back to the server in Colorado, where they then use power difference arrival to estimate locations. And so what you see here is this is all the phones that were set up in that area. The jammer was set up right next to phone 14. And then this triangle is where the estimate of jammer was. So it's pretty close. Again, this is a very high density area. So really with smartphones, the idea is that you hopefully, if the jamming is occurring in an area where you have lots of people, then you have this capability of having high density amounts of phones and be able to localize them pretty well if we do power difference arrival. And so for next test, they like to do a lot more phones. This is a project that was partly sponsored by Lockheed Martin. They like to do it in a more urban environment, so maybe to have a jammer in a place where there are more buildings and blockages and reflections that might screw up with the power difference arrival. And then also test new GNSS phones. Get back to the manufacturers, first of all, in fixing some of these issues, but also test new phones. I just recently saw, without a lot of fanfare, a lot of phones now have 3 frequencies. In the Qualcomm chipsets, they are advertising L1, L2, L5 now. Well, they're showing that. They're not really highlighting it. I just found it on their website. But that's the goal for next test. Next thing I'll talk about is the low-cost monitor that we're developing at Stanford. Again, it's kind of like a step up on using smartphones. It's going to provide more detailed information, more clear information, and also information that would help, for example, our spectrum authorities prosecute people who are doing bad things to the spectrum. So again, the low-cost monitor LCM is built on kind of low-cost mass market chipsets and some other low-cost hardware to be able to put a unit that's a couple €100 out in the field and put enough of them around key sites like an airport to protect them. It provides, again, finer information than a smartphone would be, more detailed information, and hopefully something that we can then use with law enforcement. The jamming detection is pretty straightforward. So with the U-blocks, you can actually get a spectral plot of what's happening. So that's pretty nice and pretty straightforward for us in terms of detection. We also then use that information to apply it to, won't worry about this too much, but we apply it to some standard detection methodologies might be usable on an aircraft that were being proposed for the aircraft standards, for the MOPS, minimum operational performance standards. And we're just testing to see how well those worked, given what we actually see in the spectrum for the U-blocks. The spoofing side, we did a bit of work using the fact that we have distributed these things that are distributed, but they aren't time synchronized necessarily, but they're distributed. And the fact that if we compare the pseudo ranges for a genuine signal and a spoof signal, there'll be differences that we can tell, and we can then use algorithms such as those that are being used for receiver autonomous integrity monitoring, RAIM, to actually provide a very good confidence bound and very good metric about whether we truly have spoofing or not. So this is kind of high reliability spoofing detection versus other methods of doing that. And I won't go into the math of it. That's in a paper that's coming out at the end of this month. But here's an example. We put two of them at a site kind of at the fence by the community center. We're going to go in a bit of detail. So this line is the metric that we have. If it passes 1, that's our threshold for detecting spoofing. This is during a period where there are genuine data. This is a period where there's spoofing data. This is the position error that we have since we know what the positions are. This is kind of some typical bounds that are calculated in aviation based on standards. So this is an accuracy bound, and this is a protection level, which is an integrity bound. And so they don't know that they're spoofing. So it's bounding, but then when they're spoofing, it starts not bounding because it doesn't know it's spoofing. So it thinks the errors are normal, but they're not. But we can see with with this detection threshold statistic that we built with kind of this rain-like concept, immediately it figures out, it passes the threshold and it stays above the threshold. Here you have a mixture of both genuine and spoof signals, and so it's really bad, and it shows that it's very easily detected. But here, even when you just have the spoofing signal alone, it's already captured both receivers, it still passes the threshold. So we can use these monitors to very confidently detect spoofing. So is what we are working on algorithms for. Turns out there are limitations to using these U-block receivers. They're exhibiting more and more cross-frequency effects where something that's happening on one frequency affects the other. From a user standpoint, in a good way, like if they're spoofing on L1 or jamming on L1, it kind of can figure that out by looking at L2 and L5 or depending on which receivers they are, and then it actually tells L1, oh, don't look at that spoof tracking area. Keep looking at this area where you should be at. So from a user side, like a normal user, you think that's a good thing, and I think this improvement's changed from year to year, and I think it might be because of Jammertest, because they've been to Jammertest all these years. But from a monitor standpoint, we don't want to see that. We want to see it lock onto the spoof signal. We want it to see what it would normally do without all this aiding, so we know what's happening on each frequency. And so here's an example. This is positioning during meakening day on L1, where we had L1 meakening. We never actually had the meakening position on L1 on that U-blocks, because it's getting some information from the other frequencies. It's aiding from the other frequencies. So we're trying to figure out what we can do to make it more like a monitor receiver. So we've been talking to U-blocks. I know they have a group that works on monitors, and so they might have something with that. They have years of their different firmware, so we might go back to an earlier firmware. And we're getting some data from a collaborator, Aerospace, who is also at Jammertest with raw data, and we're going to feed it in an anechoic chamber to see which version of the firmware that is least responsive to this cross-frequency aiding. So this is kind of what we'll do at the next Jammer test. Another thing we worked on was this dual polarization antenna. This antenna is just a regular patch antenna, but with it, we can get outputs for two types of polarization, generally right-hand and left-hand circularly polarized. And what that allows us to do is to use those polarizations to do processing to both. If we had jamming, we can actually create a null to block jammer. But if we have spoofing, we can actually use that to figure out direction of arrival of that spoofer. And that's what I'm going to focus on in this talk. We had two different antennas that did that. It's required they be on a ground plane. That's actually the key requirement here. And we were just logging data from those things. And what we can see is this is some of this data. So this side is from Jammertest. This side is from a different test. The two different antennas kind of work a little bit differently. But what you see here is that if we look at the phase difference, when there's genuine signals, they'll have different phase differences, indicating they have different directions of arrival. When you get spoofed, they all have the same phase difference, indicating they are from the same direction. We have a very similar thing on the other antenna. It actually doesn't matter that they're lined up here. It actually just matters where their nulls are. They have the nulls at the same place versus here they don't have nulls at the same place. Again, that's indicating what the direction of arrival is. And so here's a day of spoofing. So this area is nominal. This is spoofing. This is me getting either from receiver 1, I think from receiver 1. This is me getting from receiver 1 and 2, or so 2, and this is me getting from receiver 1 and 2. And you can see from our antenna, we get that effect. We get that effect during that whole day. When we have genuine signal, we have different phase differences, but bam, once we get me getting, doesn't matter which antenna it's from, doesn't matter what the signal is, you're getting the same direction of arrivals. We can use that to do some calculation. This is kind of looking at the phase difference that we're estimating, and we can find the statistics on the phase difference, find where the center is, and then we can figure out roughly what direction we think that Meakin error is, and this is the result from the two antennas. And then the final part is, and this is kind of really, all the stuff we're processing, but this part we're still a work in progress, and hopefully we're going to work with Natalie on this a little bit, is looking at automatic dependent surveillance broadcast to find and locate jammers and spoofers. This is our website. You can go look it up, rfi.stanford.edu. It looks at both jamming, and if you choose the other site, you can also find spoofing. So these are our jamming locations. This is from a pretty old day. If you click on it, you'll get more detailed information about the aircraft, and the flight paths are providing us this information. So we really want to make this like a tool that you can actually get deep down and analyze what is happening. And it's all coming from ADSB data. Again, this is kind of recent. This is in Poland. This has really been picking up quite a bit in the last month. There's a big jamming circle here around Gdansk, and then there's actually spoofing. You won't see it here, but you see it on the website. There's actually spoofing in the middle as well. And then, of course, up in Finland, there's a different jamming source. Here's the example of that spoofing circle that's happening. This is in Kaliningrad. This is what was reported by this aircraft. The aircraft is not flying that. Just so you know, they'll be flying a very tight 1 kilometer radius flight. But so ADSB can be doing that, and so we've been looking at ADSB data to monitor this. But we also see that there's definitely receiver effects when we look at the ADSB data, and especially with spoofing, but also a little bit with jamming. And what we don't know generally is what's happening on the aircraft, and then what the spoofing or jamming source is behaving like. But in Jammertest, we do know that. And so we had our own ground station because we don't trust necessarily the data from the provider. ADSB exchange to be not processed, to be a little bit over processed. And so we collected our own data for that. And now we want to compare it with flight data from the aircraft, and of course Jammertest has already provided the reference level of spoofing or jamming, and so the hope is to be able to do that, and that's what we're working hopefully with Natalie about, and he'll talk a little bit about what they did in a later talk. Before in the past we've always been we always just had to do it in an anechoic chamber, but having it on a real aircraft, having the aircraft body and the effects of the aircraft on it will help us really understand it a lot better. So this is a kind of result from 2 years ago that we did it in a chamber. We published quite a bit about this stuff, so we have one paper that was published in January, one paper that we published in April by us, and one paper that we published by Colorado in April in as well. And then we have 2 abstracts at ION and GNSS. And when these papers are done and available, they'll be up on our website. So please look that up. And so I'll just conclude, hopefully, if I can go to slide 4. Again, our bottom line is we played around with crowdsourced smartphones. We showed that we could do power differential arrival. We really need to characterize these different phones and improve them and iterate and improve them. And we're working with the manufacturers to do that. Similar thing with the low-cost monitor. We were able to do some tests, but because of the way the firmware of the smartphone was, we would like to improve them for our purposes. They've been improving for the purposes of the user. And then dual polarization, other antenna testing, we're going to do more and more of that, try to improve capabilities on the user side in terms of mitigating and detecting interference. So thank you for that. I'm sorry, it was a little bit of a whirlwind.
Well, I want to say thank you very much for your presentation and just take the first opportunity to ask a question to clarify. Because of Jammertest, at the end you pointed out that you were publishing based on Jammertest results. In the middle, I seem to catch a point where you said you wanted to do some retrospective analysis with data from another group via your anechoic chamber to dig into which firmware version u-blox might have fixed things at. And before that, you were pointing out, possibly complaining, that u-blox might have fixed their stuff because of experiences at Jammertest. So it sounds as though the data sharing and publication is working pretty well, would you say?
It is. It is. We try to collaborate a lot. We've shared our data with others. Aerospace is a group that we've worked with. Hopefully they'll get us data for that. They were able to collect multi-frequency IF data, so raw data that we can then play back into a chamber, and so we can test different versions. We're working with Natalie on Eurocontrol and getting their aircraft data to compare with our ADS-B data. And so there is a lot of ways that we can help each other out by sharing that, and we'll be happy to share our data with them. They want to do that analysis as well. So it's we really appreciate the environment that Jammertest provides in allowing that to happen. That doesn't happen. I've been to a lot of U.S. interference tests. That doesn't happen in the U.S. Partly because of the restrictions that we're signed up to when we go to those tests.
Mm-hmm. Well, thank you for that. Are there questions from the audience for Sherman while we have him here? Okay, well then I will ask a follow-up question. Your titles, sir? Sir, Professor, and President?
Just call me Sherman.
Just call me Sherman. You'll be happy to learn that in Norway they are so delightfully informal that they will just call you Sherman.
That's great. We're in California. We're pretty informal too. That's why I tell my students to. It's so...
Okay. Well, I would like to say thank you very much, Sherman. I'm a member of the ION, so I'll say Mr. Former President. And thank you for coming all this way to present to us today.
I thank you for having me. I appreciate every one of you. I appreciate you being a member of ION, and please join ION if you can.
That reminds me, I do need to hustle the audience to join the Nordic Navigation Forum while I have you here, but I'll leave that until later. For now, we have presentations to get to. So let me just pull up your presentation. Do you want the PowerPoint version? Or
PowerPoint, please, yes.
Nobody ever says PDF if they have both.
Okay. All right, thanks.
Okay. Please take the podium.
Great, thank you.
So Matt Humphrey is a retired United States Navy officer with a background in electronic warfare and airborne test and evaluation. His PNT-related experience includes serving as the Navy representative at the U.S. Department of Defense GPS Program Office and serving as the program manager for multiple systems integration and tactical data link efforts. Matt is currently based out of San Diego, California, and is the senior PNT solutions manager for Iridium, with coverage responsibility for the Western United States, Asia, and the Pacific region. So I have to point out again that you're the new leader for the longest great circle route to come here to visit us. That's great. We've hit a new high water mark.
Farther than Stanford, I guess.
Yeah, a little bit. Yeah, Colorado, San Diego is further.
Okay.
Yeah. And then also, if you need to highlight something on your slide during the presentation, use the little laser pointer here. I'll just turn it on.
Yeah, if you don't mind, that'd be great.
That way they can see it on the stream. Thank you very much.
Great. All right. Thanks, Aiden. Appreciate the introduction. So California time right now, it's 4 in the morning. My body is still in California time. So I don't know how Dr. Lowe does it, but I'm very much jet lag. So hopefully it makes sense during this brief today. So once again, Matt Humphrey, Iridium PNT Group. It's still a separate division from the comms group within Iridium. So we focus strictly on the PNT service that we provide. A little background, if you haven't heard about it. So time and location service has been operational since 2016. The name of it is STL, or Satellite Time and Location. It's provided by a company called Satellus, real small company, about 70 people. Iridium just bought out Satellus Iridium last year, so it's 1 year with Iridium proper. The service is now known as Iridium STL, and you can check out the website. It has information about it on the main Iridium website. Okay, the Iridium constellation itself, just to kind of go through some of the key facts for the constellation. There's 66 active satellites, 6 orbital planes with 11 satellites each. We have 14 on-orbit spares ready to go if needed. It is a LEO constellation, so 25 times closer than GPS. It allows reliable communications anywhere in the world, so we have global coverage. It is an L-band system, so good transmission in adverse weather conditions. We're just above 1600 megahertz, so just above GPS L1. We do use satellite crosslinks to get that low latency, resilient, high-quality connections between satellites and better updates from the ground stations. PNT service we're going to talk about today, it uses higher power receive-only burst signals coming off of one of the higher-powered paging channels from the Iridium constellation. The bumper sticker at the bottom, it's LEO PNT, it's operational today. We provide worldwide coverage, and there's a wide variety of fielded user equipment out there today, and it's expanding every day. Okay, for the system under test for Jammertest last fall, the figure on the left is just the broadcast laydown for where we put the broadcast regions. You show overlap over the test site and then a little bit to the north also. The main systems under test for us during the event, we call them evaluation kits or VKs. The EVK6 is our newer one. It's an ASIC-based solution. You see the ASIC chip there on top of the dime. It's going to be production ready in calendar year 2026, so we're getting ready to ramp up and go live production next year. EVK4 in the bottom right is our existing test kit we use. That's used for most of the US-based demo and test events we go to. So most of the data I'll show today is EVK4, and then I'll have a couple slides at the end showing how EVK6 did in comparison to it. Okay, so when we talk about performance parameters for Iridium PNT, there's really 3 key factors we look at. Number 1 in the top left is satellites in view. How many satellites are you seeing? You're always going to see at least 1 everywhere in the world. You get better coverage near the poles as these converge, so you're going to see a lot more satellites at higher latitudes. For Jammertest 24, we saw roughly 2 to 4 satellites for most of the time period. We've made some enhancements to the constellation broadcasting in January, so hopefully this year at Jammertest 25, we'll see roughly 3 to 6, 3 to 7. So we've kind of taken some restrictions off on broadcast to the receivers, so hopefully we see improvement this year. But bottom line, 2 to 4 satellites for most of Jammertest 24, good enough for what we needed to do. Number 2, signal strength or carrier over noise. It's really dependent on receiver design, the antenna, and the RF environment. But you can see in this chart that we roughly bounced between 40 and 75 dBHz throughout the entire period. Strong enough signal for us, good performance, no problems noted there. Number 3, burst rate or BPM, lower right. Depending on use case, how much provision signal we have in the area, how many overlap beams we have, and then the overall RF environment of the test site. For Jammertest 24, we saw roughly between 100 to 450 bursts per minute throughout the entire time period. Kind of rough rule of thumb is, if you want to do static positioning, you want to see 50 bursts per minute. If you're going to do dynamic, really depends on how fast, how maneuverable you want to be, but you really need to be 100 to 125 bursts per minute for dynamic maneuvering. Light blue box in the upper right is just static positioning. So throughout the entire test period, we saw roughly 20 to 30 meters for the EVK4, and I have a slide later on showing we saw less than 10 meters for the EVK6, but good static positioning starting out as a baseline for the Iridium PNT receivers. Okay, a couple of videos, and the good news is they're playing. So dynamic performance, this is Iridium PNT only. It's not coupled with anything, just our own signal coming down to the receiver. We had good geometry up there at the high latitudes, which was a good news story for us. Horizontal accuracy during the entire run was better than 75 meters. The map on the lower left, Iridium STL in blue, overlaying the GPS trace in red. So you can see it tracked along pretty nicely. This is no jamming, no spoofing. This is just Iridium PNT only, dynamic maneuvering. The middle graph is just the horizontal position error. You see that going down roughly from 10 meters to 75 meters throughout the entire run. And then the table on the lower right is kind of a summary of this is vehicle mounted. My counterpart took it driving. The speeds were up to 40 miles per hour. Mean error 34 meters and 95th percentile up at 52 meters. Mean burst per minute was 187 and the carrier noise is 52. So standard signal for us, good performance. 40 miles per hour is pretty slow. We've gone up to 75 miles per hour in the States, North Carolina, and saw similar performance. So good tracking as far as dynamic goes. Okay, very busy slide. Apologize for that. A lot to consume here, but I'll talk through the horizontal rows are the GNSS systems, so GPS, Galileo, and GLONASS. The left y-axis is Iridium PNT carrier to noise. The right y-axis is GNSS satellites in view. So the black trace, which is kind of hard to read under the blue dots, but that's GNSS degradation or denial during jamming. The blue dots are, of course, the Iridium PNT burst. The carrier to noise stayed in that 40 to 75 range throughout the entire time. So key takeaway is there's no impact to the carrier noise of the Iridium PNT signal from the GNSS jamming. Chart on the lower right is the same kind of table, but now it's a burst rate per minute. So you see we had good burst rates throughout the entire period, even when there's GNSS jamming going on. Okay, another video. This is GNSS spoofing performance. So this is a static Iridium PNT receiver and a static GNSS receiver. Iridium PNT was not spoofed for this scenario. GNSS receiver was initially spoofed, I think it was 3 kilometers from true position. And then I was continually dragged down with the spoofing down to 6 kilometers from the true location. Lower left graph just shows you starting at 3,000 meters and then being dragged out to 6,000 meters plus. Blue is the Iridium PNT staying static at its current location. Map on the right, same presentation, just the blue dot is the Iridium PNT receiver static with the GPS track starting at 3,000 meters away and getting dragged down to the south. So bottom line, Iridium PNT receiver was unaffected by the spoofer in this scenario. Okay, real quick, kind of comparisons for the EVK6 to show you how our newer receiver did. EVK6 showed better carrier to noise throughout all the phases of testing, roughly about a 5+ dB improvement with EVK6. EVK4 kind of topped out at the 76, 75 dB range. EVK6, we saw averages up around 80. So that was a good news story. This is our newest device, our newest receiver, newest technology, showed improvement from our previous one. And then a similar takeaway for the 2D position error. EVK6 2D error during one of the phases was less than 10 meters, where the equivalent EVK4 was showing less than 25 meters throughout that time period. Both of them tracked as expected, but we're showing improvement with the EVK6. And it's probably due to better burst detection capability with the new technology. Okay, this is actually one of our hardware partners, industry partner. NAL Research makes a Shout TSA. That's the Shout touchscreen alternative PNT. You see it in the upper right there. It's a small handheld. I have one here with me if you want to look at it later on. This is the same or a similar spoofing event. The red track is the GPS Shout. You see that's getting spoofed off, getting pulled off screen even. The green track is the Iridium PNT Shout, showing it stayed at its current location the entire time, so no effect from the spoofing on the Iridium PNT Shout. Okay, I just want to highlight, didn't have test results for all these, but I want to highlight a couple of our industry partners that played in Jammertest 24. OneWeb Technologies, that had their Astra APNT receiver out there. They connect that to the Eutelsat SATCOM terminals. Hexagon and Novatel came out with some of their anti-jam antennas, including the 310, which protects GPS and passes through Iridium PNT. And then Oscilloquartz had the 5422 out there with an STL card, one of our cards embedded in the receiver. If there's any questions or if you want results directly from our industry partners, just reach out to me or reach out to Maine Porter, my counterpart, and we can get you connected directly to these partners for an outbrief. Okay, and I think I flew through this, Aiden. I'm going very fast. So. Okay, all right. So I'll wrap it up. So contact info, Maine Porter, Maynard goes by Maine. He's our Director for Government PNT Business Development. That's him in the upper right getting interviewed last fall at Jammertest. Once again, you have our contact info. I'm based out of San Diego. Maine's based out of Washington, D.C. Please reach out to us if you have any questions, if you want us to connect with any industry partners. But please reach out to us if you need any help. Good. Great.
All right,
Very
thank
fast,
you.
sorry about that.
Oh, that's okay.
Okay.
Gives us more time to ask questions.
Okay,
right?
great.
So one of the first questions I wanted to clarify for everybody was which signal band of downlink you were using, because as I recall, Iridium has new downlink signals way up at 19 gigahertz or something, but these were the L-band signals?
These are L-band signals, right?
Yeah,
So
so-
Iridium band is 1610 to 1626. We're at the upper part of that band.
Yeah, so this was just above the hazard area. So
You're right, yeah. So we're about 50 megahertz above L1. So we're outside of that based on whatever the jammer is bringing.
But FFI was jamming GLONASS at some points throughout the test, so there
Okay.
was nearby RFI, but they may or may not have swept directly through your band, but I'm sure the guys, if you asked them nicely, would be willing to pay you.
Did we look there? Yeah. So we're expecting that to happen very soon.
Yeah.
Yeah.
So Anders, oh, sir, I can see someone has a question in the audience, so
Okay.
rather than my fake questions, let's get a real question.
Thank you for a very interesting presentation. I'm not surprising about your resilience on interference. You are, of course, on much lower orbit than what you are comparing. But as a matter of fact, I wonder on the spoofing and even more, have you tried the meconing? Can you meconing your system? Because I will expect you have vulnerability as well as the other.
I don't know
It's
that.
a curiosity, because
sorry?
is a curiosity because spoofing, I think, is due to your system. You're bursting, so essentially you skip it. But if somebody want to meconing, I don't think you can skip it. I can be wrong, but I ask to you, maybe you have done it.
I don't know if we've done it, to be honest with you. I'm relatively new to the company, so I don't know if we've done any mechaning testing at all to see what the effects would be. So.
If it's okay, I'm going to do something unconventional as chair and ask this fellow here if he has equipment which is capable of spoofing at those frequencies, so I guess above 1626?
Yeah, we don't have it right now, but we can jam it.
Yeah.
I know that during Jammertest we jammed from plus minus 5 megahertz around 1602, so that should cover up to 1607.
Okay.
So it's pretty close to
Close, yep.
Iridium. So it would be interesting to see if some of those signals were affected to your system.
Yeah, so I think the plan for 25 is we're going to still stay at this current range, right?
Okay,
But
so
hopefully in 26 we'll be able to get to expanded range.
Yeah, and you are probably in the upper band of your...
Yeah, we're at 1626.
Yes.
Yep.
But probably should ask Justervesten if they have equipment.
Thank you. So that was Anders Rodningsby, for those joining us on the live stream, who was commenting on the plans for additional signals the coming year. It's generally a rule that they're interested in always adding new, interesting things to test. So we're very happy when we see someone who has a system which is showing good performance and appears to be immune, but there is a part of us that wants to try and screw with that.
And nothing's immune. So I guess show of hands, raise your hand. Before today, who had heard of Iridium PNT? Just kind of... Oh, that's okay. Oh, get them out. Okay. I wasn't sure. I'm kind of new to the company, so I wasn't sure if it was unknown or known, and that's good to see.
That looks like you have pretty good mind share already.
Yeah, absolutely.
We definitely have to try and kick in the ribs in the future.
Okay. No, I expect that. We're getting ready for it.
Well, thank you.
We know it's coming. We just know, exactly when.
Well, thank you very much for taking the time to come to us today.
All right. Thank you.
No, it's okay. We'll use the... Control that. Yeah.
Okay, so please take the screen. I'm going to introduce you, yes. So Stefano Binda is responsible for exploring and discovering new and innovative positioning, navigation, and timing technologies in the Navigation Innovation Support Program, Navisp. Defining activities under the Element 1 at ESA Tech in the Netherlands, he is an aeronautical engineer with more than 27 years of professional experience, having covered various positions from designing and development to verification for space, ground and user equipment, in attitude determination and control, and satellite navigation. As a member of the Galileo project team, he contributed to the achievement achievement of the first open service position fix in 2013. So thank you very much for coming to speak to us today. You don't hold the distance record, I'm sorry, but thank you still.
By any means, no. Thank you for having me here. I would like to thank, first of all, the Norwegian Space Agency and all the other organizers, because these events, I think, are very important. And yes, thank you also for the mentioning the position fix. It was now 12 years ago with Galileo. And now Galileo is like GPS, a fantastic system with a very high accuracy, high availability. But I think there is a reason why we are here, and we have discovered it through the other presentations, and I will also show something here. So, yes. First of all, thank you very much again for the organization of the Jammertest, because I think you have seen now in the presentations the various aspects of the test itself, so I will go quite quickly. But I think here I wanted to mention the regulatory aspect. If we would never be able to do something like that in the Netherlands, because it's very flat, so if you start to to jam something, it will arrive from Norway through Estek to Amsterdam, so it will be probably unacceptable. So it's very important that we have these opportunities. So a little bit about the logistic. So we had a van going from Estek down up there. So there was a professional driver doing the 5,000 kilometer round trip. Luckily, our colleagues started from much closer, so the trip was much shorter for them. Still a quite important logistic effort. You can see the guys there. The locations have been exposed already in other presentations, so I will skip them. But this is more important. It's what we brought there. So our guys, I would like indeed to thank them, because they have done the activity. Luciano, Shurcho, and Nori. I'm not aware about the name of the professional driver, who is the one with the yellow jacket, but the three other guys are the guys who basically put together everything and have done the post-processing, so thanks to them. And we went there with quite a lot of hardware. You can see here a piece of equipment with 4 antennas, which are connected with a very stable and repeatable system based on the PXI standard from National Instruments. I will talk a little bit about that. Then we have a more commercial system with 5 antennas and something commercial. The difference between these two guys is that this one is 500 euro cost, so very cheap, and this one is 500 megahertz of bandwidth, very stable and very repeatable. So it's really two different worlds. Then we have also a dual polarization antenna. Unfortunately, here I don't have results for this, but I was very interested in the presentation from Sherman. We will see in the future if we have something. And then we have something very interesting, an antenna with array antenna based on the Lunenburg lens principle. I will say maybe a couple of words later about that. So mobile scenarios, again, you have seen already these, so I will go fast. The high power jamming test. So you have learned again. It's again, this is interesting because you can have a continuous wave, you can have wideband signals, chirp signals, so frequency linear sweeping signals, modulated signals, so matching a little bit the satellite signals. You can have all kind of threats, and the bad news is that they are continuing to evolve, and this is our problem. That is probably now an environment like cybersecurity, where you have countermeasures for some threats, but then you discover new ones, and you have to be prepared. In this particular case, it was a power ramp scenario. So from minus 37 dBm to 47 dBm. And you have to remember that the satellite navigation signals are at minus 130 dBm. So you can really estimate here the number is in dB also. So it's several order of magnitude bigger, the jammer compared to the nominal signal, which is buried in the noise. And here, my colleagues were taking the equipment, which is again taking different channels from the antennas, and they were implementing this algorithm, which is rather old, 1972, which is a space-time adaptive processing with a time delay line with 20 taps. So it's both space-time adaptive processing and also a sort of tap delay line, which is providing filtering against the jammer. And in the end, the results are not bad, because you can see that they achieved 55 dB of jamming suppression in the spectrum, as the spectrum that you see at the output of the processing. And then in terms of positioning, it also went better, because you see the red spots are a single antenna. If you take any of these single antenna, you will see something like that in the red. So the reds, effectively, the accuracy is going is lost after when the jammer goes above a certain threshold. But the null steering algorithm that was implemented in the end is allowing to maintain decent performance in the accuracy. So you see it stays below the 20 meters. So it's a very good result. Yeah, then I have also something about the Meaconing. Meaconing, they explain what it is. So we should go at the results. Again, the same equipment. This time implementing a minimum variance distortionless response. It's in this case the paper is a little bit more new, and one of the authors is our colleague Nori. And so in the end, this kind of processing is again filtering away the Meaconing. You have the difference between one of the channel, which is, if you notice, 10 dB above the filtered output of the algorithm itself. And then in the positioning domain, before the position domain, you see, of course, that in the C/N node there are effects from this Meaconing, also satellite going and coming, so it's quite complicated. But in the final results, you see the red spots are any of the single antenna, and unfortunately, the single antenna has been, let's say, captured by this attack, because it stays there. It stays where the signal has been captured. Only occasionally, when there was no Meaconing, it was going where the trajectory, the real trajectory was. But the good news is that with the null steering, in the end, the blue curve, the positioning performance was maintained, and the equipment was really continuing to provide the function and giving a decent positioning performance. The any single antenna was captured by the Meaconing. Then there was also this COTS jamming set up. It was explained with antennas, 3 jammers at the same time at various distance from the testing side. All the systems jammed. And in this particular case, I'm going to report 3 jammers 50 meters away from the receiver. And in this chart, we see the outcome of the implementation of different techniques. 2 techniques, the subspace and MVDR, the minimum variance and distortionless response, are spatial technologies only, so they only take into account the difference of arrival at the antennas. But the other 2, power inversion STAP and linear constraint STAP, are space-time adaptive processing technologies. Again, you see the effects of the jammers, of course. The C/N node is degraded significantly during the application of the 3 jammers. However, from a positioning performance point of view, you can see it here. This is a 95% error for the various techniques. One, unfortunately, we don't have the numbers because apparently the data or the channel were not decoded, but in the end you see that the linear constraint space-time adaptive processing is the most promising one. And my colleagues are going to, I think they have submitted this paper to a conference. I think it's the ION GNSS. So you will see it there soon, and everything is documented there in the details. Then I also learned a word, motorcade. I didn't know that it existed, so it was quite interesting. I think it has been explained. This particular test, the spoofer was in the middle of the convoy, as it was explained. It was faking a position as the original starting position, and then the convoy was moving. And we had the same data collection on our van there. So again, in this case, implementation of the algorithm of the past, so stop with the 20 tap delay lines. Also in this case, the spoofing was reaching quite an interesting level, and you see that the processing is able to suppress the spoofing with 40 dB of capability. And in terms of results on the positioning, you see that any of the single antenna, the red one, stays more or less at the starting position, so spoofing is effective for the single antenna, apart from some wandering around. But the blue, which is the output of the processing, follows the trajectory quite well. Therefore, also in this case, it is demonstrated that this processing can be effective against the spoofing. Sensor station. Why sensor station? Because this antenna is clearly very bulky, and let's say that it's probably suitable for sensor station. That's why we call it this way. And it's a Lunenburg. It's based on the Lunenburg lens effect. So the big ball is a ball which is made of different diffraction rate materials. So in the end, the principle is that you can put a feed around the antenna, and then the antenna will be able to direct the radiation, typically from the other side of the antenna. So if you put it, for example, at the bottom, the radiation will go up. And in this particular case, is a Lunenburg lens antenna, but it has also 16 antennas, around 16 feeds in a way, because it's working the other way around. Of course, it's an antenna, it's not a transmitter. And you have one at the bottom, 5 around the bottom, and then 9, as you can see, around the antenna. So it's quite an interesting beast. So 16 GNSS receivers simultaneously. These are the positions, so you can see the center antenna plus the 5 around and the 9. It's in a quite a uniform way, except for some reason 9 and 5 don't match very well, so there is a sort of offset. And so in this case, the scenario was jamming and spoofing. So nominal transmission until a certain point in time, then jamming, which blanks basically the frequencies. This is the output of another receiver with another antenna, is what we call the test user receiver plus an AVEX antenna. So this standard receiver simply was blanked by the jamming. Then the signal comes back, and then spoofing is applied. So this is, as the chairman was also showing, spoofing gives you even a higher C over N node sometimes because it's closer and it has a decent power. The signal is not so dirty, let's say. So in the end, effectively, gives you 55 dBHz, which is quite uncommon for a navigation receiver, I would say. And this is the way for any given satellite the antenna respond. So in nominal condition, of course, the receiver which is really below the satellite is showing the highest C over N node, and the others are lower. Then during the jamming, you can see that it is still working. Of course, the C over N naught goes down. And then during the spoofing, there is also something peculiar here that there are more than one direction which are giving you an higher C over N naught. So I'm not sure this is the end of it, because we have really to experiment more and to find a better processing of it. But at least the fact that you have several high C over N naught signals for the same satellite from different directions shows you that there is something abnormal and should be treated probably in a lower, in a further processing stage. So very interesting result. In terms of functionality, in the end, you can see that on the left, sorry, on the right, the standard receiver with the omnidirectional antenna simply stops tracking during the jamming test, and instead the receiver with the lens antenna continues tracking with a lower C over N naught. So again, a confirmation that array antennas are probably the best line of defense against jamming and spoofing for any navigation receiver. Then one point on the connection to Navisp, which is operating at the level of technology and product and services in navigation. This object was indeed procured under a Navisp project. It was an Element 3 project because the hardware itself, the one which is shown here, it's quite powerful, but it was not only not the only deliverable. Let's say this project was supported by Hungary, and the idea was to set up really a test center to be able to understand the impact of interference, spoofing, and other threats on PNT, on position, navigation, and timing technology in general. So this output that we got, now we are using for the Jammertest, and it shows again the link between Navisp and the important subject of PNT resilience. I think is high on our agenda in the program to support resolution, or at least addressing properly PNT resilience. And also in Navisp we are developing technologies at the user level, and this one was an Element 1, so it's a technology development, Element 164, so-called block box. So a lot of technical details on the hardware, but the bottom line is that this was conceived as an equipment, very simple equipment that you can put in line for any satellite navigation reception chain, and then it is able to detect attempts of jamming and spoofing, and is able basically to filter the signal for receivers which don't have the same capabilities. So in the end, from a, if you like, opportunity point of view, it could be deployed in any situation where you have already a lot of infrastructure deployed. You don't have the money or the will or the understanding to replace everything, and you just put in line between an antenna and a receiver this technical solution, this equipment, and this equipment is cleaning the spectrum, the output from the antenna, and making sure that the receiver later on can work better. And you can see here the difference between the performance of a standard receiver and a receiver with this block box in the middle. Again, the Jammertest was very useful because this was not carried on site, but the signal was captured on site and then on the Jammertest side, and then brought in our laboratory, and then we replayed it and proving that this equipment, the block box, is effectively working against interference and spoofing. It was a very useful experience because in the end, effectively, we couldn't have organized it in another place ourselves, but it was good to be at the Jammertest 24. We collected more than 100 terabytes of data there has been also some promotions on our social networks. But more importantly, I think this data now is available at ESTEC, at ESA ESTEC in the Netherlands, and anybody who wants to play with those data maybe can also come to us. Our colleagues in the Directorate of Technical and Quality, they have now this service, and for a moderate amount of money you can access the data and facilities which are there for the good of everybody. Okay, so I think that I want to thank again the organizer for the Jammertest. I think this is what is needed because only testing solutions in the field with all the impairments, multipath ion effects, tropospheric effects, dynamics is, and of course jammer and spoofing, only doing a test you can really claim robustness and resilience of your equipment, so it's very welcome. I think at ESA we are very interested. At ESA we have also a program which is Navisp, as Pierluigi explained, that has PNT resilience at the top of our agenda. We like to work with government organization for the part which is related in paradigm, protect, toughen, augment. Protect is really for governmental organizations, spectrum management and so on. So we work very well with governmental organization, like for example this element 327 that I showed was procured in agreement with them. But there are also of course commercial opportunities for the toughening of receivers and equipment in general, array antennas, and there are also technology developments in the realm of research and development. And on this subject, I would like to say that as the manager of this part of the program, we are defining now the work plan for next year, so technology developments for 2026. And if you have any ideas which goes in this direction, PNT resilience, also more general in the position, navigation and timing, I would love to hear them. So thank you very much for your attention.
And thank you very much for coming to share all of this with us. It's exciting to see when someone not only takes a van, but hires somebody to drive it 5,500 kilometers, then uses it to collect 100 terabytes, and then goes back and does it again a couple of years in a row. Yeah, because it was 23 and 24?
I think so.
Yeah, that's impressive. So does anyone in the audience have questions? Come on, it's a rare opportunity. No? Okay. Well then, I guess I have to ask you a question. Were you aware that on Norwegian highways you have to legally have your lights on even during the daytime?
I was not aware.
Neither was your driver.
So you did, really?
I had to send Luciano an email saying, hey, you got to turn your lights on. And he said, okay, I told the driver. And then next time they went by, they had the lights on. But,
okay, but I'm surprised because it's a rather new Mercedes van, and I thought it had already the auto system, but so not rely on the automated system there for the moment.
I have to bring it up because that guy's the safety officer and he watches me like a hawk.
Well.
So,
Apologies.
Any real questions? No? Okay, then thank you very much.
Thank you. Thank you.
Come on up. Yeah. Thank you. Okay, this is Radek Reznicek. Radek is a software engineer and scientist at Honeywell Aerospace, member of the Integrated Navigation Team. He develops jamming and spoofing protection solutions for hybrid GNSS INS systems to ensure the safety and reliability of commercial aircraft navigation. Thank you for coming. We look forward to hearing from you.
Thank you. Thank you for being here. I would like to present you what we are doing, how we utilize Jammertest, and what are our, let's say, outcomes, what we learned, and how we utilize the data that we collect. First, I will say that we are focused mainly on civil aircraft navigation, which is usually certified solutions. And since the issue is increasing for past few years, it's a really hot topic even for us. So I like to say that we try to find an antivirus for a virus that is right now in the air. Let's go on. What was the Jammertest for us? So far, the biggest live test campaign for data collection that we did. Actually, we lose against ESA. We only 18 terabytes of data. And also, unlike ESA, we were driving ourselves, so almost 7,000 kilometers in a van. That was a nice drive. But actually, we successfully tested our new anti-spoofing and anti-jamming prototypes with GPR system, that is GPS-aided attitude and heading reference system. So that was it was really successful event for us. First of all, I would like to tell you something about how we do it. We develop something we call DRASM. It's a dual receiver antenna spoofing monitor. It is basically should work as a software upgrade for current hybrid navigation solutions. We are consuming the data from different sensors, mainly from GPS, also air data. It's kind of a modular architecture, so they are different variants. We can have single antenna, dual antenna, with air data, without air data. So we have several sub-blocks or sub-monitors that we use to make the whole system more robust. From the GNSS, we mainly consume the ARINC 7438 data. So we try to apply the solution for current systems, also looking for future ones, but the current systems has also or can be affected. So we try to make the monitors on platforms that are right now in the aircrafts. How we do it is we have something that is called FuseNav framework. It's mainly developed in MATLAB and Simulink. It has several blocks. First is sensor processing, then there is a jamming spoofing processing, and then there is the algorithm itself. This is something that is very modular, and it's we can simulate the data with some sensor modeling, error models, etc. We can also replay the collected data, which is very beneficial, that when we collect the data, for example, on Jammertest, we can replay it with different settings, different things. We can develop new things based on that. And then we can deploy this whole algorithm to our prototyping platform or to target product platform. It's on the picture there, it's H2000 product. And how we test it. So we have kind of a big platform bringing in a van. It's not just the targeted platform that we have there, but since we go such a long way to Norway, we want to utilize Jammertest as much as possible. So we have multiple GNSS receivers, multiple recorders, and other systems, multiple antennas, etc. To collect as much data as possible for additional analysis or for another future improvements and products. We also record the raw data on X300 from Etus. And we also have some commonly available receivers just for some comparisons or checks. And here comes probably for you more interesting part, what we learned about the GPS receivers' behavior. First, I will start with jamming. High power jamming usually just saturates the spectrum. We lose the signal. It's a challenge, but I think that we can. it doesn't crash our solution because we have hybrid system. We can continue on inertials. It actually doesn't push any false signals to our algorithm to crash it. We work on solutions to mitigate jamming, not with the scope of Druser monitors, which is based on spoofing monitor. But spoofing is more, I would say, interesting for us because if we let the spoofed measurements into the system, we can actually crash the whole hybrid solution, causing some misleading information. I will start with meconing. Meconing, I would think, is a common issue because repeater can be very cheap to put to the ground, start transmitting to the air, and maybe I will mention the text in the red box down there that the time alignment is the key for spoofing. That's why we are not saying that our receivers are easily spoofed by meconing, but they are easier to be spoofed with meconing than, for example, with generated spoofer, and that's because the meconing is basically very well synchronized. Now I'm not sure, but I think that 1 kilometer is something like a 3 microseconds propagation delay, something like that. So the meconing is very well synchronized with GPS time. If I tell about generated spoofing, if it's generated something like offset position, generated trajectory, and it was a well synchronized scenario on a Jammertest, it's easier for us to be spoofed. But if there is some time offset, and for us it didn't have much difference if it was minute, 5 minutes, or 5 years, the receivers are really fighting against the signals. They don't want to track it. They don't want to go on the spoofed trajectories. So the time is the key. There was, but yeah, maybe just to mention, we mainly analyze our receivers for commercial aircraft aviation. So this might not apply for other receivers commonly available on market. There was one very nice spoofing case that was S-bus spoofing with MT0. Do not use GPS. It was interesting, caused loss of GPS. So that one we have to focus on as well. Now I will show you some graphs, and later on I will tell you that we were a little bit cheating, but there is actually CN0 commonly presented because that's actually with the magnitude of data you can see something on the presentations in the graphs. So there are the white segments that are without spoofing, and the red segments that are receiver actually spoofed. So you can see that there is observable change in CN0 trend. It's a little bit less noisy variant, or how to say it correctly. So that's just one case. We are not monitoring just CN0, a lot of data, but the problem is how to show it on a presentation because of the magnitude of data. You will have to really dig deeply into the graph, zoom it or something like that to see the difference. Another case is like time push. It was, for example, on the left graph, I think it was time push of 15 minutes. Clearly visible trend that changes the time of the receiver. On the right side, there was a published trajectory and the receiver following the spoof trajectory. But now I get to the point that our intention was to get spoofed. Because our algorithm utilizes the GNSS measurements data, and if we are not spoofed, we basically don't have nothing to process or analyze. So first we need to be spoofed to make our monitor having some results. That's why we were cheating. I will show you why. We were by the purpose, we were restarting our receivers at the beginning of spoofing. Not all of them. We had multiple pairs of receivers. Some of them we let them alone to observe the behavior. But the problem was that when we were observing the behavior, it took the receiver a long time to get spoofed, or it wasn't spoofed at all, because the receiver doesn't like the spoofed signal. It has some kind of, it is somehow resilient to it, but I'm not saying it's not possible, it just takes time. And since there are a lot of scenarios, different kind of scenarios on Jammertest, we won't be able to collect much data if we just rely on the receiver will be spoofed by itself. So we helped it a little bit with the restart to collect as much data as possible from the spoofing, so we can better analyze and validate our algorithms. The key output of our algorithms, when we process all the data, analyze the spoof data, we basically rise a spoofing flag, not just that, but this is the key one that goes to the algorithm, and it prevents the algorithm from being contaminated with the spoofed signals. So we can continue with operation without crashing the algorithm. Basically, the last slide is that I would like to thank organizers for this great event, because this is really necessary part for us to for the product development and actually smoother transition from just prototyping to product. And if I just can have a wish, if we are accepted for next Jammertest, we would like to see some exposure of spoofing longer than 30 minutes in a row, to see what is the algorithm really doing if we are not cheating, not resetting the receivers, if we are actually spoofed or not, would be really great. So yeah, that's all from me, and thank you for your attention.
Well, thank you very much for presenting that. It's always funny to hear about situations where you can take a system that should be a source of integrity, spoof a small bit of information that tells it don't use any of that other stuff, and it says okay.
Yeah.
So yeah, that was your experience with the SPAS spoofing?
Yeah, that was the experience. But yeah, that was, I think there wasn't so much SBAS spoofing, but we mainly focus on normal spoofing. We can always disable SBAS. So yeah, but a very interesting case, and we need to be careful about this.
We've also found in lab-based simulation that there are some parts of the almanac message that are decoded in GPS that have added flags over the years that now say whether or not the satellite has L2 and L5 present, and if you set those to 0, it goes, oh, okay, I'll stop tracking on some receivers. So that's an interesting type of vulnerability to see in the wild like that. Does anyone have any real questions for the presenter? Yes, let me grab the microphone here. The WebEx won't hear you if we just let you shout. Yeah.
Thank you very much for the presentation. I was curious that you also had magnetometers on board. Did you collect any data? Because I think navigating with the magnetic field of Earth, or better with the anomalies of the magnetic field, is also something which is quite interesting lately. And I was wondering if during a test like this you can see any impact from the electromagnetic radiation, which is of course electromagnetic, into the magnetic measurements. Thank you.
Yeah, so this wasn't our main goal, but yeah, we had magnetometer. It's one of the input to our system, providing the heading. We have version that can utilize GPS heading. By the purpose of this test, we didn't use it, so we use heading from magnetometer. But to be honest, we had to shrink our limits for magnetometer model for our testing, because the magnetometer was placed on the rooftop of the van with and the field of the whole van is very bad for the for the magnetometer and going inside to our algorithm. So we had to shrink the limits to be able to use it with less precision. But it wasn't our or intention or scope of the Jammertest to analyze the data from it.
We have time for a follow-up if you would like to ask. No? Okay. Anyone else? Yes.
So I have a question regarding the inertial platform that you have used during the test. So you have mentioned that you have used a GPSRS. Why this kind of inertial platform and not a gyro laser inertial unit or something like that?
Probably I missed the last half of the sentence. Can you repeat, please?
So why you have used a GPSRS and not other kind of inertial platform, like for example a gyro laser, IRS, or?
Yeah, we use it. We use it. Yeah, but still, that inertial platforms consumes the data from GPS. They are aided with that, and that's the issue. That if we push the false measurement into that IRS platform, if it's completely out of the way, I don't know, spoofing like several hundred kilometers or dozens kilometers, I don't know, it will probably exclude the measurement. But if you are, for example, close enough, like on the Jammertest, we were spoofing within kilometer or 2 kilometers, you can actually adjust the inertial hybrid solution with the false measurements, and then it can cause like deviations. So this is important to protect. So only coasting on IRS, I think it's not enough.
Okay. Thank you.
Okay, we have time for one more. Going once, going, oh, here we go.
Thank you. During this test, were you able to simulate kind of a carry-off attack on GPS? Like being perfectly in sync and then very slowly drifting away from the original GPS signal?
Yeah, actually, I think there wasn't any test that would be so precisely targeted. We do this in a simulations in our lab, but there were mainly some collateral spoofers on the Jammertest for everyone. So targeting our van, if you meant this, no, that would have to be a really specific case for us. That's we don't target specifically for this.
Thank you.
I agree. We should give the Jammertest organizers more funding for cool equipment so they can do targeted and phase-aligned attacks. Thank you for bringing that up.
Thank you.
Thank you. Can you please thank the presenter once again? We are a couple minutes ahead of schedule, but we'll simply proceed. Okay, the podium is yours. The only direction is if you're going to use the pointer. We'll just turn on the little laser pointer here so the people on the stream can see it. Thank you. So I'd like to introduce Espen Olsen. Espen is Chief Investigator in the Southeast Police District with more than 15 years of experience within the Norwegian police, built in areas including intelligence and investigation. He has been involved in the development of case law in Norway, but today will be sharing his experiences from Jammertest related to the use of satellite communication systems for police and official purposes in contested environments. So thank you for joining us.
Thank you. Hello everyone. My presentation is going to be of two parts. If the clicker works, it doesn't. Okay, I'm going to talk about LEO SATCOM in general and a project I've been working on the last year, and I'm going to then go to the findings of Jammertest. But a couple of caveats first. I'm a police officer with a technical interest. I'm not an engineer, not a physicist or a doctor or academic, but I'm more interested in what I can get out of the output from the systems. So that is my main concern. Sadly, some of our findings I can't share with you. Sorry. And my experience is primarily with the SpaceX Starlink LEO terminals. So that's it. So with that out of the way. A little bit about our project. we have been looking into how we can reinforce the ecom systems in the police. And you can remove the word police and then use the total defense if you want to, because it applies for everyone. The project, it's supported by the Space Agency, and we are very grateful for getting the opportunity to do this. And I have worked 1 year totally nerding with LEO terminals. I work at the National Emergency Response Center, and we do provide whole country with specialized efforts like counterterrorism, bomb disposal, counter-drone, and many other things. And we wanted to know, this is so exciting, we need to know more about this. And that's why we got this project running, and it's very user-centered, always testing things, and very practical. And again, it's SpaceX Starlink I have most experience with. But we see that by looking into Starlink, we also gain a lot of knowledge from other things. So we were looking at 3 use cases for us. One, this is from an article on Svalbard. Somehow the fiber connections is destroyed. Strange. It happens also in the Baltic Sea, and that's one of our use cases. We lose connection. The next use case is there's a congestion. There's a lot of people, too many, and our communication, our needs are not met because they are all using TikTok, and we get jammed. And the third one, we are operating in very remote areas. And picture 1 and 2 can almost be the same, because if you are on Svalbard and use connection, it's going to be like this, no communication. And of course, we also look at Ukraine, and we see what happening there. Right before the Russian invasion, the Ukrainians did a lot of things, but at least 2 things that for me stands out. Number 1, public records were moved into the clouds. Very, very fast with the help of Amazon. And why is that important? Well, if the office that had the records is blown up, you have a problem. Because even in wartime, pensioners need to get their pension, and so on. The society must continue to function. And the second thing, the cooperation with Starlink and other providers, and getting things still running, even if infrastructure is being hammered daily. And for us, this was inspiring and needed to be done. I try to put this in a kind of simple context. This is my world view of communication. We all use these internet systems. We use Teams, Zoom, we have our networks, and we have internet for everything else. I have mobile phone, 4G, 5G, right? And then I have my radio. It could be digital. It could be what you call in Norway, Nødnett. And we have Satcom. You can talk and you can use data. And what happened if something bad happens to it? What if the lines are cut? Because there's a common thing with 2 of those columns. All the internet somehow goes in the ground in a fiber cable somewhere. All our radios also goes in the ground in a fiber cable. So they are dependent on what happens on the ground. So, if the equipment is not destroyed and we have power, this is what happens, at least in my view. We're not going on TikTok anymore. It's gone. We have some function in our radios, but it's much, much worse. But hopefully we can have normal operation on satellite. That's why we have to look into this. And for now, and for the audience here, you all know this, I'm pretty sure, but we have for now two alternatives for LEO satellites, for at least for now. And the two ones are Starlink and OneWeb. And when we looked at how Starlink has evolved extremely rapidly, it was a no-brainer to look into this. And they also had a price point that even the police could afford it. So that's why the last year have been extremely exciting. We have been in Svalbard, high up north. We have put antenna on ambulance boat in the northern part of Norway. We have been driving a car for several months along the Russian border. We have been using it in operations with the cruise ships. And because we lose connection when we go alongside the ship, we have been using it with 5G and creating mobile 5G base stations. And we're putting on snowmobile and we use it on exercises. We gain extensive experience in the last year. And we've been tracking everything by using small computers with the Raspberry Pi in them. So what have we learned? We have learned that it works well, and the bandwidth is good enough for our users. And here's a nerdy part. If you look at the graph, and I shall bring out the laser pointer. These are two antennas in northeast of Norway, Kirkenes, and this is in Trøndelag. And you can see what we are measuring here is packet loss. Oh, sorry, it's ping, the time needed for response from the server. And you can see it's have an average of 70 milliseconds in Trøndelag and 80-90 in Finnmark. And this is now comes the nerdy part. Then we calculated the amount, how far is the road in Norway to go to Kirkenes and to Trondheim, and what's the distance between the cities. And we know that it's a common thing in all of Europe. Fiber optics are placed by the roads, and we calculated how far would the light use to go from Trondheim to Kirkenes in a fiber cable, and that is around 20 milliseconds. So what we learned from that? We learned that the usage of LEO satellite in Kirkenes is no worse or better than the use in Trondheim. Okay, so we have identified some things. The performance is good. The coverage is very good. The mobility is good to acceptable, depending on the antenna. It's very cost effective. And it has a huge potential for our use. But there are also some disadvantages. It can be jammed. You need to have it out in the open. It's not so easy to hide. The bandwidth is limited. There are reports of congestion in some places. Performance goes like this, up and down, with at least one of the systems. Ownership, just keep it hanging and then put it away. Security, not that it is probably not bad, but we don't know. And we don't have national control of the data because it goes to centers outside Norway. And sometimes there's a best effort, no guarantee. But anyway, we see three things that is very useful for us. Using it as a regular data carrier, internet, with just a plug, internet. We can use our radios over satellites. It opens up the possibility to stand on Svalbard, almost in the North Pole, and talk to the South Pole with a radio, because the satellite is a link. And we also have seen that we can use it for 5G base stations that we can just put up. Based on that, we have 4 things we have recommended to the government. We have to think about digital resilience in a holistic view. There are nothing that is... Oh, let me rephrase that. If someone asks me, do you want Starlink or OneWeb? Yes, please. More. I want Kuiper. I want Iris Square, and so on and so on. I want more and more. We have to work with the commercial actors, so it's this is one place we can talk to you. And we also have to diversify, not put all our eggs in one basket. That's very stupid. And we have to start deploying equipment, and we are doing that. Okay, Jammertest. This is our test site. We had 4 antennas out on the grass there. 2 of them were just control. They were on the whole time. And 2 antennas was shut on, off, on, off, on, off, and booted in different conditions. But before we went there, we did some homework, some prepping. And this is the point where the engineers go like this. Okay, because we have read on the internet that you can make the Starlink antenna better to receive GNSS signals. Okay, so we went on the School of YouTube, and we opened antenna and see what we could do. And the friend who's helping me, he's an engineer actually. Yeah. And we found the GPS chip, and we soldered it away, and we attached another antenna in the hopes of getting a more GNSS resilient Starlink. The result and the moral of the story, it didn't work. But we learned something. We learned something, and that's the point here. We learn by doing. And if we had checked that guy's second video, it was how I destroyed my Starlink. So learning by burning. Okay. So what did we find at Jammertest? And this is actually kind of the boring part, because the Starlinks were working normally. Even if GNSS was jammed, they were working normally. So we started to shutting them on, off, on, off. We went outside, we turned them around, on, off, and they just worked. And we also had a mobile Starlink going around, and it also worked as normal. And this is from our system, the system we use to supervise the test. And this is our packet loss. And we had a small dip around 2020. Beep, some data had been sent over. And then around 2052, we turned the antenna off and rebooted it. And we did this for 3 days. So it got kind of boring, but quite reassuring. So that, I guess that's a good thing. But, and there's a big but here. We only know how it reacts when GNSS is jammed. We don't know how it's going to work when the transmission itself is going to be jammed. And we know from open sources that the Russians have the capability to do that. That's a problem. But how on earth did they manage to get it working? Well, that's what 4 years of warfare gives you. Necessity is the mother of all inventions. And we have from our colleagues that the errors that was found in 2023 was gone in 2024. So it just describes the constant cat and mouse game in jamming technology and building resistance. And OneWeb has also built something with Astranex, a Iridium product, or a part of Iridium. And it gives the OneWeb a very good resilience to jamming. And we know that the Russians are extremely good at electronic warfare. And we also have reports that they're not trying to jam the Starlinks. It's more efficient for them to track the Starlink and then use artillery and drones to take out the Starlink. And that's why we are very curious and how we can do what we can do to protect ourselves. So, is it a good idea to cover up the Starlink? Is it a good idea to bury a hole and put it down in a hole to make it difficult to find? We don't know. So what are we going to do now and forward? We are definitely going to explore the jamming of the transmission. And during this year, we are confident that LEO-SATCOM is the new big thing. And we're going to work on how we're going to protect this capability we are now getting. And we also know that we are going to return to Jammertest 2025 because we are preparing for a police operation all over the nation, and we want to have the advantage these systems gives us. And in a very bad scenario, we have to prepare for a total conflict, but these systems are going to be very, very challenged. So, after when I drove home from Jammertest in my mobile home, alone, with my dog, this is what I thought. This is my conclusion. Protecting yourself from jamming is tough as hell. So the first step is to knowing when it's happening so we can actually do something about it. So don't forget your PACE plan. And don't forget your paper map. Thank you.
Well, I really have to salute you for trusting Professor YouTube like that. But as you said, sometimes it's best to start at the end of the lecture and work your way backwards.
Learning by burning.
Yeah, learning by burning. And also, though, I was surprised to hear that the Starlinks had no problems at all, because I had read years ago that there were problems when GNSS was jammed, but as you said, 4 years of experience, or however many years of experience, they had time to patch things, and it looks like they have.
Absolutely.
So is the plan this year for Jammertest to include KA and KU band jamming, or is that just on the wish list?
That's on our wish list, at least.
Okay. Anders, is that a thumbs up? He's saying maybe. He's saying maybe. Ask him again.
Maybe that's a yes.
Yeah.
A weak yes.
That's a request for more information. Yeah. So are there any questions from the audience? Anyone? Well, we have one right here. Lars. Let me grab the microphone for you so the people on the WebEx can hear. There you go.
Thank you. One question concerning the SATCOM link to the Arctic. We also have the ASBM system, which is operational. Have you been looking into that?
Definitely. I would personally, I would hope that we could have a slice of that pie, very much, because then we have a total control of data and everything. But even if it's ERIS Square and everything is implemented, I still want a Starlink. I still want a OneWeb. I still want a Kuiper. Yeah. More systems. Yeah. Redundancy is king.
Well, I hope they can afford to give you the budget for that and to replace the burnt one. So thank you very much for sharing with us today. Well, I have to say we are frighteningly close to being on schedule. We have one more presentation today. So let me just get the slides set up and I'll call up our next presenter. So there you can see your presentation.
Yeah,
One second, I must introduce you first. Everybody, meet Natalie Cacciapoli. He earned a dual laureate degree with honors in radio electronic navigation and telecommunication engineering from the University degli Studi di Napoli Parthenope. Sorry.
That's fine.
Since June 2017, he held the IATA AVMP designation issued by Stanford University. In 2003, he was appointed as fellow researcher at the G. Latmiral Engineering School, granted by the Italian Aerospace Research Center, working on GNSS signal processing. Since October 2008, he has served as a GNSS operational validation expert consultant at the Eurocontrol Innovation Hub, specializing in GNSS aviation applications, including SBAS, GBAS, ARAIM, and RFI. He actively contributes to the development and validation of the Pegasus tool, assisting Eurocontrol project stakeholders in assessing the technical feasibility of GNSS system prototypes. So, please take it away.
Thank you very much, Mr. Chairman. And I wish to thank you for the great opportunity to come here and present our results. So, as Sherman already introduced about the ADS-B data analysis for GNSS RFI on the aviation side, so here I am to talk about the GNSS RFI indicator that will be integrated in the future dual frequency multi-constellation receivers that we are supporting in the framework of standardization of future dual frequency multi-constellation SBAS minimum operational performance standards for civil aviation. So which is the drawback of today? Today, ADS-B data analysis require interpretations. So our objective here is to contribute with an RFI indicator on board the aircraft that can clearly broadcast the information to the air traffic controller saying there is or there is not an interference on a given band, such as L1 or L5, or there is no data computed by the receiver, avoiding so the interpretation of the ADS-B data, and as well as avoid to charge the air navigation service provider to provide additional infrastructure, additional cost for monitoring of those informations. The agenda for ESA, the enabling onboard RFI detection capability, the RFI indicator specifications, validation objectives, then the flight test equipment, and the performance for few cases, because otherwise we will not go on weekend. It's almost there. So the RFI event analysis, I will show you a real operational scenario. Unfortunately, in East Europe, colleagues already shown lots of time the sky data show this interference, but there are people of Europe that they are going home there, and then we do care about the safety of air navigation operations in those airspace. So I will show you one of those kind. So the RFI indicator requirement specified in current EuroCAI document 259B, its DFMCS bus MOPS, are proposed just to facilitate algorithm evaluation through flight testing and support coordination with the surveillance group for integrating the RFI detection in future ADS-B version 4. So the ADS-B version 4 will foresee an updated message with additional information about the interference that has been detected on board an aircraft, with much more information for us engineer. So the RFI detection information can be downloaded to INSPs, Air Navigation Service Provider, or Air Traffic Controller, essentially to enhance situational awareness and allow proactive problem management, as well as support decision-making to maintain safe aviation operation by ensuring GNSS independent surveillance and communication system are functional at the same time. So enable timely alert, such as issuing NOTAM. NOTAM, it means notice to airmen, or reporting incident for radio frequency regulators, as well as the RFI detection information can be used to enable radio frequency interference detection capability on board the aircraft to support both flight crew awareness to help identify the root cause of system and function alerts, and maintenance operation as well. This is to help in distinguishing between equipment failure from signal in the space anomaly, reducing the unnecessary maintenance actions. So here a little bit of mathematics, just to let you understand what I will be talking about. This is the RFI indicator that the authors of working groups at the EuroCAI Working Group 62 and RTCASC 159, we are working on it. So essentially, we are monitoring the carrier-to-noise ratio of measurement of the receiver, normalized to the number of satellites that they are satisfying the satellite use criteria. Essentially here, the satellite use criteria define that the satellite is locked, continuity locked, and the code redundancy check of the ephemeris, it's okay. So we can use the satellites. So we do monitor this parameter, and then we do use a sliding window of 1 minute to monitor which is the maximum delta between the minimum and max of this carrier-to-noise radio standardized average, the carrier to noise ratio has been detected over a sliding window of 1 minute. So I leave you the rest of the requirement just to, if you wish to analyze it offline. So essentially, the validation objective of Eurocontrol have been fulfilled, validating the RFI indicator requirement using real flight data collected in RFI-free environment, including high dynamics, to characterize the RFI indicator probability of false alarm. Because you understand that monitoring carrier-to-noise ratio, it's quite tricky because this is sensitive to aircraft maneuvering, like banking, of the aircraft when in an approach to a runway over an airport or maneuvering during normal operation, and as well as in controlled interference environment, essentially Jammertest, when we know that an interference was broadcasted. This is to evaluate indicator performance against jamming, spoofing, and meconing as well. So the operational scenarios, we have performed several flights around Europe where interference regions are very well known. This is in Cyprus Island. We did perform the flight test over Europe with aircraft with calibrated antenna and certified avionics that nowadays are providing navigation to normal operations. And the Prague-Tallinn way coming up to Andoya. So my colleagues were able to collect the real RFI signals that can be experienced on board the aircraft. So the RFI indicator performance results have been presented, as I said, at the EuroCAI Working Group 62 and the RTCA Working Group 2 Special Committee 159, that they are working on the standardization of future receiver for aviation applications. So our presentation here aims to share our results with the participant of Jammertest and express our interest to get the test scenarios on L5 V5A band during the Jammertest 2025. Hope you grant us to come again. So here I have been able to exploit the data from a past project that was funded for SBUS GBUS application, the DREAMS project, where our colleagues and even Eurocontrol, we have been able to collect dual frequency data, not only on the ground, but also on board the aircraft. But since the scenarios was quite convenient for the characterization of probability of false alarm of this RFI indicator, because we were not sure 100% that there were no interference there, because unfortunately we had, at that time of the project, no enough information to say if a real interference was present. So then we exploited these scenarios to define the L1, E1, and L5, probability of false alarm, the characterization or distribution of the delta max I have showed you before. And there you can see the 95 percentile of delta max and the pseudo probability of false alarm in both bands. So you could deduce that since L5 it's a little bit higher power and better resistant against multipath, of course, the probability of false alarm on the L5 it's better than L1 is. So this is what we could have there. But on the other way around, you know that L1 is a better mitigating ionosphere effect than L5 is. So at that time, I did fully checked that multipath and ionosphere likely were very quiet. So that's what we got. But this is only using 18 hours of flight data in challenging dynamic maneuvering of the aircraft. And this was in Netherlands in Twente Airport. So for the flight test for Jammertest 2024, our flight inspection aircraft with the calibrated antenna and certified avionics was equipped with the certified antenna with the FAA Technical Standard Order C190. Sorry to spell out all those acronyms, but for aviation it's very important to say to which standards those comply. And then we used a commercial off-the-shelf receiver. This is Novatel PowerPack 7, and here I am to express my gratitude for the law and agreement with Novatel colleagues, letting us use this technology to validate the RFI indicator. So then the raw data collected from the receiver, it can be processed by our tool, Pegasus tool. I know some users here inside the room. And then I have developed the Pegasus RFI module able to analyze the spectrum data, not only ranging measurement and navigation, to characterize the performance of RFI indicator. So during the Jammertest 2024, we did the aircraft. We could cover 4 days on 5 forests, and then 11 hours of flight data was collected, and we could analyze 57 scenarios. But here I'm not going to talk all about them, just a few of those. And essentially, for us, the short baseline between the source of interference, Blake, Grunwaden, motorcade, and the airport was challenging for us to say which source of interference broadcasted the RFI, because those were running in parallel, and the aircraft flying over, having an oversight of all of that, for me has been very challenging. So here I am to talk about just RFI detection, but not geolocalization. So here is. This is a case of 10 September, the flight path for Meconing and the jamming signal scenario broadcast. In a green line, I have shown essentially the path as computed by Pegasus tool. The Pegasus doesn't work in real time, but in post-processing. And when this path is red, an RFI is detected. Then the highlighting colors for each side show you when a given scenario was broadcasted during the aircraft maneuvering. So we can see very well that our colleagues before, they did show, I hope you can see the mouse over here. So when Blake, the main source of interference, was looking over the sea, so we expected this, but sometime over here as well. So I go much more in the details. So the RFI indicator has a sliding window of 1 minute to learn what happened in the past, because we didn't want to overload the crew on board the aircraft with a blinking alarm. Imagine if you are driving a car with something blinking on the dashboard. You will be bothered with your technology and you will switch off. So we wanted to model the RFI indicator in such a way it gives an alarm and stays stable. That's why you see extended, let's say, path with red. And here you can see that Meconing did work very well. Pegasus did computed the position on the Blake rooftop. And then there with my colleague David, we were having fun. Thank you very much for this fun. So, you know. Okay, so here I am to express again my best gratitude to the colleagues of Jammertest about the test log. Thank you very much. This is a sterling job, because I could import in Pegasus the test log data, and then I could correlate each interval or broadcast of RFI with the timely data. Over there are strange numbers. Those are nothing else than GPS Galileo seconds, starting from aircraft takeoff and landing. From where? From Evenes. Sorry, Norwegian colleagues, I don't know if I pronounce well, but you will teach me. So, as I said, this is the carrier-to-noise standardized averaged value that we are monitoring. And the third plot from the top, it's the RFI indicator when an interference was detected by our RFI indicator. You can see that essentially it triggers an alarm when we have big ruggedness. But please, here the aircraft was still in Evenes. This is the takeoff and land. That's why for each plot, starting from this one, we are not seeing detection at the very beginning and very last epochs of the flight. The last plot from the top reports essentially the interference mask as is today specified in the SARPs. SARPs are standard recommended practices for a standardized minimum operation performance receiver. And here I do report, in function of the frequency and the power, the RFI components that we have been able to measure. So this means that the RFI indicator can detect interference inside band, so essentially inside the interference mask, and even a little bit outside, as it was the case for this particular scenario. And if you would like offline to go through my slides, you can very well refer to the test log, a catalog, to see what it was broadcasted during a given test, because you have the test paragraph that is reported on my slides. So you can see that essentially the detection are very well correlated with the Blake site, because not only was the much powerful one, but of course the other one, they could interfere when the aircraft could go back to evenness, but the power was too low to don't have an effect, essentially. This is what I can empirically analyze from the data. Here something much more detailed. So on the very top of the first plot, I did a report again. Highlighted the intervals with the broadcast of the interference from the three sites, Blake, Grunewalden, and Motorcade, and again the carrier-to-noise standardized averaged value. And the second plot from the top reports in green line, it's the number of satellites visible. It's the number of satellites that in post-processing we have been able to compute using genuine almanacs that we could download from NASA website for GPS and Galileo Reference Center data provided. So then you have the dark blue, it's the total number of satellites that could be used, and the light blue's value are GPS and Galileo satellites that we have, because there with Pegasus we compute GPS, Galileo, L1, standalone position solution with a smoothing of 100-second time constant, so the MOPS position. The blue line here and the red one are essentially the test statistics of the RFI indicator and the detection thresholds of 6 dB. So as soon as we detect a 6 dB change, variation time, we raise an alarm. Or when there are not enough satellites to compute position solution, let's say when we have less than 4 satellites. So then here I report the RFI indicator with the timely alarm provided, and the one bottom over here, you can see the commercial off-the-shelf solution provided by our colleagues on Novatel, of which I don't know the implementation, and they can use much more advanced technique and parameter from the spectrum that we can do. So you can see that those, the answers from the Novatel receiver and the one that we propose in the standards are well in phase each other. When you see a yellow triangle over here, the receiver say to us that is spoofing. If it's a red dot, this is jamming. Just to say to you that we in a standard receiver, we don't have access to automatic gain control. So we are really limited in the analysis. And so here, just for your information, I reported the normalized horizontal distance and the slant range distance between the computer position solution on board the aircraft and the sender position in Blake. The very last one, I did report the aircraft bank angle. Here, unfortunately, you know, sometimes during the test, things don't work, so we don't have good attitude data of the aircraft. So I did estimate the aircraft bank angle from the estimated position of Pegasus. So when it's spoofed or jumped, unfortunately, the banking angle, it's nowhere. So, but this is just to say that we don't raise false alarm during aircraft maneuvering, because you have seen the aircraft did lots of turns above the interference source. Here it's my joy, really. Thank you very much for the Jammertest organizer, where here with Pegasus we had spoofing of position everywhere. So here the position, so it's something very strange over here, but yeah. And this is position jump and small position jump with initial and continuous jamming. And jamming, this is the flying one. So the position of Pegasus jumped around Scandinavia, then Pacific, Atlantic Pacific, and then even beyond the GPS and the Galileo position solution. I'm happy to say, because it's not only us, as well as the certified avionics on our aircraft, and also our colleagues on Novatel, they were both in the space. So I say this, why? Because at a given time, we had no visible satellites. And my colleague said, Natalie, something is wrong. And then I said, no, they are all below the elevation mask. They were below our foot, so there was nothing. So we were in the space somewhere. So just to go fast, I don't want, yeah, I'm already late as usual. So you have, so both the answer of the RFI indicator and the commercial off-the-shelf solution that you see, again, they do answer, let's say, in correspondence. They are very well correlated on the time, but you can see that for aviation application, we did a design, the RFI indicator not blinking, as I said, but a constant answer. So here the objective is that the RFI indicator, as here I show the path going from Prague to Tallinn. So if our colleagues went with the van, we had the pleasure to go with our aircraft. So, and then experience the RFI all around Europe. So here we report what it would be in the next future. So when the aircraft fly from A to B all over Europe, if there is an interference, the RFI indicator, we hope very much that it will detect, it would be not a false alarm, reporting the information in the ADSB, facilitating the work of our colleagues that they are analyzing ADSB data, saying there is or there is not, on which band. So when you see here the red dots, it means an interference has been detected. And this is the case that we were expecting over Poland, Lithuania, Latvia, and Estonia. So you can see that here the spectrum was so much saturated that our receiver loss of lock of all satellites. So our software could not compute position solution because our software doesn't have an RF front end. So we are fully dependent from the RF front end of the receiver because we take very easily very simple binary data or RINEX data. Or we did record as well IQ data, but we played the IQ data in the laboratory on our Novatel receiver as well. So here is the flight from Prague that you can see it's everything. The aircraft was taxiing on the airport and then taking off. When the aircraft was taking off, higher value of bank angle, you can see superior to 10 degrees, let's say 50 can happen, and we don't have really a false alarm. Here, what I can say to you, that unfortunately this is a data gap. Here it's my error of reporting. I just connected 2 dots that they were spare in the time, so it's not a decrease of the number of satellites that they were locked. And here we can see that the standardized carrier-to-noise ratio slowly shades until the aircraft reach the border with the Estonia. But here in the room, experts could challenge myself saying, why here the Novatel receiver did provide an alarm and not your RFI indicator. Because I can assure you that our colleagues that provide certified avionics on civil aircraft today, they are very good in mitigating those kind of things, and we think that over here an enough number of satellites could be used for position solution. We know if it's a spoofing, would not be, let's say, flagged, but you can see here that the delta max was very close to the threshold. So it's just a matter of how close the aircraft was to the source of interference. But then you can see that we flag the alarm just before silence and then just before the final approach in Tallinn airport. So I done. So essentially, the RFI indicator, we can say from the 57 scenarios as well as in RFI-free environment, that it reliably detects all form of RFI, jamming, spoofing, and meconing. And its performance essentially goes beyond the initial intent to detect only jamming. The RFI indicator consistently triggers alarms during RFI scenario. Indeed, it reliably sets and clears the RFI detection status as we wanted. And it constantly engaged in all observed instances of receiver position and time offsets. So for additional analysis and activities are ongoing to further characterize the behavior, the RFI indicator. As the Chairman said, the investigation of the ADS-B data, so it will start, but on our side, I'm at a good point because we were also gathering ADS-B data directly from the avionics. So we didn't use ground receiver, but directly on board the aircraft that I could correlate with the GNSS. And I hope next time very much that with the Chairman we can come back with much more details. If you would have any idea to share with us, thank you. Very much. So then, another important activity right now, we are directly supporting Airbus in processing and analyzing data collected from certified avionics, where MMR stands for multimode receiver, in RFI operational scenarios, such as we did with our aircraft over Europe, essentially in assisting in validation effort and most important, advancing the potential integration of RFI indicator in existing aircraft architecture. This is sincerely my dream, that today the current architecture of aircraft that brings home to holidays, to home to work, could benefit of the work in EuroCai Working Group 62 and RTCA. At TCA level. So to support the validation of EuroCai document 259B, where the final version publication is foreseen in 2 years, we would like very much to coordinate with the organizer, if you grant us the opportunity to come. And I would like to have also jamming, especially spoofing on the L5 band, because this is meant on the both band. If we can do that, you will contribute very much to the safety of our navigation, not only in Europe, but all around the world, bringing safely people at home. So thank you very much for your attention, and thank you for the great opportunity. If you have any questions, sorry, Chairman, I got all the available time. So here I am. Thank you.
I think it's better that we listen to you than give me more time to talk, because all I have now is the final notes. So this, I was more than happy to let you finish.
Yeah. Good strategy to don't have questions.
Well, actually, no, hang on. We have a coffee break for everybody, so I want you to find him at the coffee break and ask whatever questions need to be asked. So thank you again, Natalie.
You are welcome. Thank you.
So he might not have traveled the furthest to come here or to Jammertest, but you have to agree that his collection platform was indeed the highest and fastest involved, whether or not it was reporting the correct position. So I only have my final things to say here before I let everybody go. And first off, I just want to say thank you to Siri, Camilla, and Christian, who helped co-organize the event and in fact did most of the work. It wouldn't have been possible without you guys. And I would also like to thank the co-funding bodies who have helped us put on this event today. So it wasn't just the Nordic Navigation Forum. We also received support from Statens Vegvesen, ROM Center, Fugro, NTNU. I'm sorry if I'm forgetting everybody, but it wouldn't have been possible without the assistance. So thank you to everyone. And as a last word from the Nordic Navigation Forum, I would like to say that in the interest of supporting the navigation community in the Nordics and beyond, we will be hosting some webinar events coming up soon, which you can see on our website, nornav.org. In addition, we're offering a master's student prize. So if you know a master's student, or if you yourself wrote a master's report in the last 2 years dealing with navigation, we're offering a 5,000 kroner prize to the best applicants. And we also use it to give us additional fodder for presentations to share with everybody what interesting things are happening. So if you know anybody, please nominate them to us. You can find the information on our website. With that, I would just like to say thank you to everybody who has attended. You've made today a special event, and please join us for coffee. Thank you.